The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality was stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everybody, welcome. My name is Nathan, otherwise known as Old Man Builds. We got Papa Bale in the house today. How's it going, Papa?
Good, Nathan. Thanks for having me.
Dude, looking forward to this, man. Oh, what we got there? Nice. Let's get that little ringing going on in there. That's like Joe's favorite things from all your videos, man. He tells me about that one all the time. Yeah,
it's a nice piece. It's wall art, but it's beautiful wall art.
it's awesome, brother. So I wanted to show you this real quick. This is and I'll send you that link. This is the piezo disc we're talking about.
Yeah, that's a lot more piezo.
Yeah, it's kind of thick too.
Yeah. Okay. Sweet. Yeah, I don't have those. I need those.
Yes. So I was telling Papa Bale backstage that they use them in systems not just as a piezoelectric disc, but as a capacitor. So it's made of barium titanate. So you're getting it to fill fast and dump fast into your coils and stuff for saturation purposes. This is what Mike was doing. I'll show you the coil that I built for his motor here real quick. I was telling you earlier, it's a 2-pound core. That thing's a monster, man.
Yeah, that's awesome.
Whoa. There we go. Things falling off of it. So here's the cool part.
Very nice core. Very nice core.
I just pull the cores out of it.
Oh, that's so cool. You can interchange the cores.
Yeah, so
yeah, that's beautiful.
In there, I did the math and I did all the holes in there, and each one of the rods individually goes in there. So now they're spaced out 100% evenly as you do it.
That is, you made a little nook for each rod is basically what I see right there.
Yeah. So
that's
there's
awesome.
You can see the thing. It looks like a big barrel.
And they're insulated. That's awesome. That's awesome.
Yeah, Mike told me, he says I will oversaturate the core if I don't. And he said to tape each one. And I said, well, I don't know if I want to tape each one, but I can definitely do the 3D printer and make that work out for me. So, yeah, that was pretty awesome, man. I did that for that one. I wanted to show you those, man. But I wanted to talk to you a little bit about your counter-rotating motor. So, for those of you out there, this is Otis T Car OTCX1. The design is for counter rotation, and there's very few people that pulled it off. And Papa's got this thing running smooth. Let me just tell you that right now. So he didn't build the UFO device yet. I would love to see that, but he's got the counter rotation down pat. And I'll just describe it for everybody, and then we'll probably play one of your videos. He's got all the electronics in the center, and then he's got magnets on the outside. You want to go ahead and tell people how that works?
Yeah. So like the electromagnetism is on the rotor. So as soon as you put the coil on the rotor, you then have to put the circuitry and the power on the rotor as well. And it's different than your typical pulse motor with having the permanent magnets on the rotor instead of the electromags. I'm still finding a way to like balance it because it's really there's a lot of material there there's a lot of components. So I think I'm going to learn how to solder here in the next couple of weeks, realistically, um, to get rid of all the connectors, which work or they don't work. Sometimes they don't work, and honestly, you really have to take the whole thing apart because you don't know which one is not working, and then you build it up, a piece at a time and test it, make sure it works, and then you continue. But that's that. There it is, in one of its various stages. Um,
That's amazing. You built it just like the Utron, and then the
yeah,
centers rotate. Yeah, see, it's free to go. I see the magnetic coils in the center there. Now I see
yeah,
why you're talking about the switch. I see the little switch on the outside right there, or the
yeah,
inside, I should say.
yeah.
I think they sell those at Amazon for like $20.
The but I'm
The
trying to replace those with
the on
you
and
know,
off with an infrared button.
yep, yep.
Yeah, absolutely.
Because
Definitely
when
get
you put
those.
the cap on it, you can't stop it the way I normally stop it with my finger. That's pretty dangerous. But
Yeah,
it's worked so far. So far.
we're so far. No, my fingers are still here so far.
We're gonna end up calling it the 9-finger journey.
Yeah, there you go. You lost one in order to figure out you needed a remote. That's great.
Yeah.
I absolutely love that. Let me see if we got this thing rotating, man.
If I turn this one,
Yeah, see if you turned it on. Oh, there we go. Hold on.
that might not be on though.
Oh yeah, you definitely got
Yeah.
it. Okay, it was
Okay.
right around the corner. Here we come.
Yeah, it looks on to me, the switch. So I'm gonna spin it pretty soon.
So to get this started, you just give it a little spin. Is that
Yeah, yeah. I like to spin it one direction because I stop being able to stop it better that way. See, I
okay?
stop it and I go the other way with it. There we go. There we go. And see, it doesn't take anything. As long as it can do it, it'll automatically do it.
Oh, that picks up speed quick.
In the middle, yeah, yeah, yeah. And then the torque is pretty nice with 6 magnets on the outer stator.
Now I see why you want everything soldered. Those little pin things probably come out every once in a while.
Yeah. And you don't know where. It's like you don't know where it happened. And it's like, oh man.
Oh, absolutely. Yeah,
I
let's
don't
see
think
this
I'd
thing go.
run it without duct tape.
Yeah,
Like
we all want to achieve that someday. I trust me. I still got a lot of duct tape laying around myself. Yeah, look at that thing go.
that might actually just be me pushing it either way. Um,
Now I can see it picking up speed right now, just as you're going. After you slowed it.
that's that self-running capabilities that I was mentioning, I think. Because yeah, that was definitely the pickup coils are hooked up to cap banks that are feeding a circuit. And this one, there's 2 transistors in the white breadboard, and then there's 1 transistor in the red breadboard. And then one of the ones in the white one is hooked up to the cap bank, and the red one is hooked up to the cap bank. And like when you get all these batteries and everything working in this tiny little area, I don't know. I got this resonant hum. It's
Mm-hmm.
like a, and it was really, and I'm like, that doesn't sound good, but I don't think it was really dangerous or anything. It's just, you know, uh, uh, I need to make them work in more synchronous. Uh, Go ahead.
Have you ever seen the video of the guy who takes a diode and puts a capacitor over top of it?
No.
Okay, so The reason he does that is the capacitor is acting similar to the diode. They're almost the same thing, just at a different degree. But what he does it for is to get rid of noise. So by taking out some of the energy there, it changes the frequency. So they say DC doesn't have frequency, but they say that it has a certain level. Well, that certain level is frequency. I'll just give you the answer right now. So what happens is you get things here, and then one's here, and then one's all over the place. So because it's destroying it, and then it'll destroy your rotation and everything. So if you put a capacitor over top of it, sometimes it heals that real quick, so that the sound through it is perfect. It matches the sound of the actual device going on. It gets rid of hums. Hums in a system cause hysteresis. They cause heat.
Yeah, yeah, I noticed that. But so what do I got to put a capacitor across which part?
So if you have a diode going one direction,
Right.
you'd basically put a small capacitor over top of it. So here's your two wires coming out of it, right? Both sides. You
Right.
just put one leg, wrap it around, the other leg, wrap it around. We're talking very small amount of capacitance. And we're the little tan looking ones that you get, the tiny ones,
Right.
things like that. I'll link you the video and send it to you so you can watch it yourself. But that's what gets rid of hums out of systems. Is
But you
your
need to have a diode in there, like across from the base to collector, and then
not always.
Okay, so I don't have any diodes in there right now.
Okay. Well, then we just need a small capacitor in order to level it out.
Okay.
That's all we need, because you're somewhere in there. Your frequency is, they call it noise, but
Right.
it's causing problems in the system. It's
Yeah, it
causing,
is.
yeah, it's causing an imbalance somewhere. So
So
it's
you
kind
see
of,
that. Okay,
go
go
ahead.
ahead. All right,
No,
the
no,
90 degrees going. So you got well, I mean, this video and then the build that I have right now is totally different. I could describe it to you.
okay. You have another video of the build. Let me
Um,
let me
let me
see.
think here. Just finished rebuilding. Just finished rebuilding.
Is the name of it?
Yeah. The Utron counter rotator. But I don't think you're gonna need that. And I stayed up till 4 a.m. last night, just putting this thing together like 8 different times. But look at how much is on there now. There's like a
Oh, hold on.
it's only
Let me put that on loop. Oh wow. Yeah, it's a little different.
yeah, there's now 4 circuits on it instead of just the well, I mean, it's just a different layout, really.
Wow, that thing's fast. We keep getting this. I don't know. Oh, it's a short video.
Yeah.
Here I am looking at it going, what the heck are they bringing up on my screen? No, we're good.
Yeah. That's it, man. And that's
Man, that sucker's moving.
I need to get it in a shape in a condensed form so that I can put the the other cone on, the cone on the top.
Oh, okay.
It won't go on there because look at how bulky it is now. I mean, even when it was like the way it was before, that one actually might have worked though. I mean, it was like really tight in the middle and everything, and it might have worked. I don't see this one. The angle's all wrong.
So are all the circuits pretty much the same?
Yes, right now.
So if we basically made it into a circuit board and made it smaller, then you'd probably be okay, right?
Yeah.
Like the size of a ZVS or something for each one of them.
Okay.
So something like, maybe this tall, maybe this long, this wide. You know what I mean? Like a square on each one. So you have modular units, and you could just plug them in or solder them in, you'd probably be okay with that.
Yeah.
We'll have to. Is it an easy circuit? Pretty much like what, four or five wires connected to something?
Yeah. It's I call it a 1-2-3. It's basically a Bedini circuit with no diodes and no resistors.
Oh, okay.
So you got your base, you get a light though. The light bulb, that's part of the circuit. So you got one for the base, two for the collector, and three for the emitter. So 6
Okay.
altogether. Yeah.
Well, if you send me the circuit, I'll redo it and get you a condensed version that you can solder together quickly and get rid of everything out of your way.
So yeah. I'm definitely trying to minimize it. So I need to reduce the weight a little bit. There's lots of different things.
Well, that'll do it right away. I mean, you're going to reduce a bunch of that stuff off the top. No more
Yeah.
breadboards. All the chips will be laid down. Oh yeah, you get rid of all that.
Sweet. I would really like to see this come to fruition. You know what I mean? And I mean, with the way that I build stuff, it's kind of reached its climax, and I need to learn a different way to put stuff together because I want to keep going.
Yeah, well, you already have it done. I mean, the only thing you need to do is now condense it. That's the easy part.
Yeah, I guess it's gonna. Well, I mean, if it, yeah, learning stuff is something that I'm bringing into my life again because I just totally, anything, not just conventional learning, but it's like I'm learning disabled, not like literally. I mean, maybe I was, but I'm not anymore. I'm eager to like figure out what I need to do to get that thing to move and keep moving without like blowing up because it's so off balance. 1,000 RPMs, that thing's just gonna go. Whoosh.
Kind of my favorite part, but yeah, I know what you mean. It's not your favorite when it's flying at you. Yeah,
Yeah, dress up in your catcher gear. You know, you got to have your pads on,
yeah.
your
Your
face
face
mask.
shield on. You know what I
Yeah.
mean? Back to the old days of shop. You know what I mean? Everything's falling apart, flying at you.
Well, I mean,
No.
if might be able to like get like an aerial camera view
Hmm.
and like put a shielding up around there, that little space that I work in, and maybe I'll let her rip like that, you know, just in a controlled environment.
Yeah. So you're not playing like 51 card pickup. You know what I mean? You're not picking up
Yeah,
every
or
little PCB piece off the ground.
digging some glass out of my arm from the light bulb,
I tell you, I've been there before, man. I can't tell you how many times, but I've been there before. Let something slip on a grinder and it flies back in your face. Yeah, been there.
Yeah.
So yeah, you know what? Yeah, we condense that sucker down and get you going because all it is basically taking your circuit, soldering it together, and just have like a little board that everything's on.
Yeah.
And it could be just like one circuit, two circuit, threes, four. You know what I mean? And boom, boom, boom. You can just hook them up individually, which then makes it a lot easier and a lot smaller and compact. And yeah, I've done that several times for mine. So I'm over
That-
here designing a whole bunch of parts. That's what I do, man. I sit on my little CAD and I design parts to make sure they fit in the little spaces. So, because I like
yeah.
everything neat and particular.
I need to make a new rotor and I need to make it with like little compartments for all the batteries and everything so I don't have to use glue, and well, maybe a
Oh, there you
little bit
go.
less glue. You need to keep it in there, but like, yeah, if like make a perfect size and then no glue. No glue. No glue would be better.
There you go. No glue or have it when the top goes on, it's in such a place where it never moves. That's really what you want. That way you can open it up, show it, put it back on and run it, because those things, man, the Utron looks awesome in its self-rotating, but expand that out to a UFO, man, and that really looks like something slick.
Yeah, my second it's a Utron, but it's half an Utron, but it's cut in half. The lower
Mhm.
half's cut off. So it does look like a saucer. It's really, really heavy though. I mean, and you're gonna have to do that one over again too. Uh, but it's basic, you know what I'm saying? If you can imagine just the cone, and then you cut off the tip of the cone or half of the bottom of the cone, and then
Yeah.
that's exactly I thought the same thing basically. I'm like, this, and a saucer would work better with the shaft. You know, it would just be a more, sensible option.
Yeah, I like it, man. Well,
So
you could play with different sizes of this stuff once you get it going. I mean, it looks like you already have most of the right components everywhere where it needs to be anyway. So, I mean, I'm still in my infancy of pulse motors, to be honest with you, Papa Bale. I,
yeah,
just getting my Bedini. I just finished that one, and then I'm building the Renegade. I'm almost done with that one. I just got to put everything to the board now. I've been tortured over the last 3 days. Let me just tell you this: the last 3 days, it's been like 4 hours of sleep a night.
oh
I've been
wow.
building Tesla coils every day for 3 days straight.
Well, people love them. People love your Tesla coils, man.
Yeah, yeah. So I've
Oh,
been driving myself nuts, man, because it's like I feel like a zombie. I go from one part to the next part to the next part. You know what I mean?
yeah.
And then I go to the circuits and I test everything and make sure it's good and stuff like that. It's man, it's a wild ride, but I've been trying to get free out of it. I'm like, there's got to be time. I'm eating and sleeping like a couple hours, come back, make sure to change the printers out because you got to get all these parts printed. Yeah, it was a nightmare. But
I'm
all
drawing
that's
this circuit for you.
okay. There's a shout out, Sean. I want to shout out Mike earlier. He came in, you know, Mike Faraday over there. He got some awesome stuff going on his pulse
Okay.
motors too. So just want to shout out everybody in the cryptos in the chat, man. Talking about my Tesla coils. Funny. Yeah, but we've been building them in. I got to get in there and I got to spin some more wire. Let me tell you right now, those things are a nightmare. Like, it takes me about 2 hours to spin each one because I didn't like the way that my motor on it was pulling the wire.
Right.
And when I got done, it looked like it thinned out. So the aesthetic was garbage, even though it worked, it works perfect. I just said, I'll just spend the extra time to hand wind them and do it right and make it look perfect. You know what I mean? So it takes me a while to get those things spun. So usually I take a day and just trip out in my garage and just spin, 5, 6, 7 of them in a day, and then barely can walk for the next 2 days after that. You know what I mean? Because my back's so messed up from being hunched over.
Yeah.
I got the old lady's glasses on. They're down at the tip of my nose like this. I'm like, you're like little magnifiers, man.
Yeah. Like Benjamin Franklin.
Yeah, there you go. I, I I feel like that as I'm building these things, man. But
Like this.
yeah, there you go. That's me. That's me hunched over that thing. Let's see what you got.
I don't know. That's a real quick sketch of it.
So we got an
That's how simple it is.
NPN,
Yeah.
NPN battery. I see a light and I see coils.
Yeah.
So is a light like a neon?
It can be a neon or a halogen bulb. The halogens do 120 and the neons do 90. So for voltage anyway. That's the only difference I see. They're both filament based bulbs.
So you're tripping the collector and emitter together with the light bulb. Is that what I'm seeing
Yes,
there?
yes. The collector and the emitter are connected through the filaments in the light bulb. Yes.
Okay. Well, that's not that hard. That's a pretty simple circuit. Is there more
Yeah.
than that to that, or
No.
is it just 4 of those?
It's 3 of these, and Then the last one, I'm not sure if you need to know all this, but the cap banks are connected to 11. There are two super caps that add up to 1110. So 11 volts, 10 farad. So the cap banks dump into those, and then those draw. And I think I need a PNP for
Okay.
the fourth one, to draw the energy out of the cap banks, just in case it's not flowing naturally. I think a PNP circuit would really help right there.
Yeah, because it pulls the energy through. So instead of pushing it through, it pulls it through. So on the backside, just shake it out. Yeah.
I think it would really improve the performance to do a PNP for the last one. And I'm not sure what that diagram is. But like the simplest one you could possibly imagine, basically. It's basically what this NPN connection is. Without the light, that would be the simplest you could make.
Gotcha. So we're basically making like little mini tank circuits.
Yeah.
And we need a PMP tank circuit. That's all we need.
Yes. Yes.
Which means where your hot and cold come in. So on your last pin, the third pin, it would either be positive or negative to the power source. If I'm not mistaken, the PMP is positive to the power source there. And then negative goes in and connects with the wire that goes into the coil in your tank circuit. And that's the PMP. It goes before the resistor goes into the PMP on the input.
Okay.
Sorry, I'm just trying to remember. I just built a bunch of them yesterday. So yeah, that's basically the backwards circuit of the PMP. It looks so much like the NPN. If you didn't know the two wires to mess with, you'd never get it right and start frying transistors all day.
I think that's what happened to me with it. I got discouraged with PNP, and I stopped doing it. But I need to know that too, just as well as I know NPN.
Mm-hmm.
And I don't know it very well. I mean, this is the circuit that I use pretty much for all of it. I probably need to incorporate, a diode maybe, and a resistor possibly, just to protect my, equipment. Right. I mean, I don't. That's what it's for, right? To protect.
Oh yeah.
The equipment.
Or you get a like an over voltage one.
Okay.
What do I want to call that? I forget the name of it right offhand. They use it in Tesla coils. It's basically if you get a runaway and it tries to push back to your circuit, it pulls it off in a different direction so that it goes over the capacitor instead of going back to your system and frying all all of your transistors. It'll go back and pull it off and dump it into a cap. So it's a high energy spike, like a back EMF you get once in a while.
Is it a fat diode? Is it?
Yeah, it's a snumber circuit.
Oh, number circuit.
Snumber circuit. So a snumber circuit is just when you have your diode going out, say like if you use it on a Tesla coil, it's going out to your number 2, right? Yeah. It basically goes on and it'll connect to that, okay, right above it. And then anything that comes back to it, it pulls it out this way. So it's on top of the diode here. So it pulls it out this way and drops it into a cap so that you never get something that just fries it. And then you have some kind of resistor in there in order for it to go one way. So it'll go this way. It'll look at the resistor, say that's not the easy path. I'm going this way, right? Mm-hmm. But then when it comes back, it'll go, well, that resistance is very small versus, the diode. So we'll go through the resistor and then we'll pull the energy to the cap.
That makes sense.
Basically, it's number circuit. Yeah, so it keeps you from frying everything. It's one of the things that I'm going to add into my Tesla coils. And it kind of is like a secret little weapon. So I use it on my Tesla coils in order to pull some of the energy out, keep it in the cap, and then push it back to the Tesla coil when I want to. It's like an extra energy circuit to fry. You know what I mean? If I want to add like another 10% to the actual Tesla coil's output, I push the button and it goes, vroom, shoots the extra 10% in the energy plus what was already getting, and it makes it jump.
That sounds awesome.
Got a little trick procedure, man. Keep everything
So
going.
tricks of the tools of the trade, pulse motor tool of the trade. That you want to know how fast you're going, you're going to need one of these. This is a tach meter. Um, it's real simple. Uh, and this is another trusty tool that I've been suggested to get. This is a component tester.
Hmm.
So, like, to see if it's working or not broken, what it is. It'll tell you everything.
Absolutely. I have both of those.
Very cool. Yeah.
On the RPM one, did you when you go to replace the little tape because you run out of it, is there like a little black tape that you get? Because I got a silver one and it didn't work all that well.
I'm sorry. What do you mean by tape?
What do you put a little piece of tape that they gave you with that infrared thing there on the coil, or excuse me,
Yeah, yeah.
yeah, that piece. Because mine was like originally when I bought mine, there was a little black piece of tape, right?
Okay.
Now I tried to get a silver piece of tape. I mean, the Amazon said would work, and it didn't work.
Oh, well, I use tinfoil and I try to make it go across the radius of my
Oh,
entire thing so that, yeah, like the shiny side of the tinfoil was what I use.
oh, now we got some tricks going on there. Okay, shiny side of tinfoil. So if I just tape a little piece of tinfoil to it, it'll
Yeah.
give me the RPM reading correctly.
Yes. If there's nothing else that it's picking up on, that's the only thing it's picking up on, then you'll get an accurate reading.
Hmm.
But like if you're using neos and it hits the neo, you're probably going to register another hit, just because of the color. Yeah.
Gotcha. No. I'll be good with that. Certain things, man. After you run out of certain stuff, you go to rebuy the new stuff. Doesn't quite work as well as the original. So that's good to
And
know. I'll have to try that.
what I know is the extent of what I know. You get what I'm saying? So like if I know about something, I will, give my 2 cents, give my opinion,
Mhm.
um, give you an answer. Uh and like just recent, it's like the answer that you would give would be contradicting a different answer, like somebody else's answer. And it's evidence that this field that we're in is expanding
Mhm.
and the understanding is growing, uh, you know, really quickly. And I noticed that, this term that was this way, 3 weeks ago is now not even considered towards, things like over unity is a good example of that. It's like 3 weeks ago it was like this, and now we understand better and it's like this. So I think it's great. It's going so fast. Like that's why I named my video Fast Fast Fast. Because it's so not necessarily overwhelming. Um and what I'm getting at is I don't know a lot. I do not know a lot. That's why my circuits are so simple, because that's the extent of what I know. And I know it very well. And I know when it's working, I know when it's not working.
Mhm.
Um, and pretty much the way you change this circuit is you change your coil. That's how, you operate with this one.
Well, I'm there with you, man. I always say I got a ten component rule. I like to build things under 10 components, make them simple, make everything where everybody could understand it. Because once I get past 10 components, you don't know what the components are doing anymore. Like you'd have to get some kind of degree to figure out what I'm trying to do here. You know what I mean?
Yeah, sometimes you feel that way because there's a lingo. There's a
Uh-huh.
linguistic, part that goes along with this whole thing that, if you don't know it, you could feel that way very easily. Like, you know, um, like there's a learning curve there that is might take a degree to get, you know?
Yeah. Well, I'll be honest with you, man. I know when I first started, I'd see things in a system that you couldn't really have the words to describe yet because most people, try to take them out of the system or something like that. So there's no real good word to say that, really puts out what you're trying to get accomplished or that you're seeing in a system, but it's there. And I would get that a lot when I first started. And I would always get confused between the A, B, and C fields, you know what I mean, and what's going on. And so I just stick to where it was. And then what I did was I started to do stuff over and over again in repetition for it. It's like remembering somebody's name. I can't remember anybody's name like the first time, but if I see him, I talk to him, and I interact with him, I do it. So now I just write that down every time I get to the top of the paper of what it is, and boom, I can remember it. But that's just me. I have a weird way of learning sometimes, and then other things I just pull out of my head that are absolutely nowhere, and it can make them work. And I couldn't tell you how. It just made sense to me. So, but I'm there with you, man, on this lingo thing. Some of it's the same thing, but it's just in a different environmental condition. And as soon as you change that, everybody thinks it's something different. And I've learned it's kind of the same thing. Saying different words. It's just that, they don't understand what I'm trying to say. I get that
Yeah.
one a lot.
So I was, I made a video about, what happens in my counter rotator. It spins. It's a DC brushless motor, and I accidentally used the word create DC energy. And that was a big no, man. I got a huge backlash on using the word create, and just all this physics just came. Physics, that's all, and it all came. It's like you cannot create or destroy energy. I'm like, dude, I freaking know, I know, and you feel better now. It's like
I'm right there with you.
I screwed up, man. It's all right. Let's move on.
Oh man, I get some hate mail for some things I say too. But yeah, they always say that, but then when you ask them how it really works, they don't really know.
Oh yeah. Oh no.
I say, okay, well, then how is the energy getting in there? Because it's definitely getting in there. So how did it work? Oh, I don't know that, but I know you can't create or destroy it. But why are you getting on me about words then? You know
Right.
what I mean?
Yeah. It's like it happens, and you're gonna get over it, but in the moment, you're like, God. Please. I mean, I've only been doing it for 3 years, maybe
Uh-huh.
3.5 now. And I think that I've it's been a slow uphill trajectory. It's
Hmm.
been like that. And I think because of the no editing fact of my channel, it's gonna like stay like this or maybe even straighten out. So that I thank you for giving me that DaVinci Resolve.
Absolutely.
I hope I'm allowed to say that.
Oh yeah, absolutely.
Okay, cool. Yeah, man. That's gonna help out a lot with smoothing stuff out, probably getting more people to stay longer.
Well, it'll help you get your point across too.
Yeah.
Be- Sometimes you write a little script and little piece of advice. If you look into the camera and do it, make sure that you have a screen with your bullet points on it, or like a piece of paper with it, right there next to the camera, so
Yeah.
you don't forget. Because I get into talking about something and I forget the next point, right? So it's always nice to have that little thing right next to the camera to do that. That way you could focus on the camera, because sometimes you get wandering eyes. So You ever see this? You're doing this, and you're like this, and then you're talking,
Yeah.
and yeah, and you're like, man, are you blind or something? And, no, I'm okay. I just trying to read what my script said, right? So just keep it right next to the camera lens. It would save you a lot of time, and then everything will come out smooth because you know what you want to say.
Yeah.
It's putting it all in sentences all the time in front of a camera when nobody's there will drive you nuts. Like I do it all the time. It's two paragraphs, right? You think, oh my god, how many times have you said this on a live, and you just can't say it to a camera? And if you saw my outtakes, it'd be like, oh, I'm yelling at myself 90% of the time, calling myself a fool because I can't remember one simple word of the whole thing, and it causes this giant train wreck of what's trying to happen, and there'll be a giant pause in between that and that word, and yeah, oh, I can tell you the nightmares, man, about filming. And it probably would be the funniest thing to most people, but I'm so embarrassed about it. You know what I mean? It's I only tell you because you're going to run across every bit of it when you're trying to get out what you're saying, and you're going to go like Nathan told me. He told me this was going to
Nathan.
happen.
Yeah. I mean, just to get there would be great. That would mean I'm not stuck in the mud anymore.
Yeah.
And I feel like if I don't learn, if I don't do the next step, I'm going to get left behind. And that's really what's going to happen. I mean, everybody's going to keep moving on. And if you're stuck in the mud, you get left behind. It's, so I know what I got to do. And I'm going to keep doing it. Oh, well, I'm going to start doing it. It's more like it.
Well, the good thing is I've watched your channel for a while, and the ability to put new things in there, to try new things, you have all of that. That's the curiosity. You know what I mean? Does this really work? Does that really work? And then when you get new things, you're not afraid to put it in there. And then when it does work, you get it to a point where it's like you're peeking out on how it works, right? So you go, okay, barely got it running to now I'm so efficient at it, I can do it in my sleep. And that's what I really enjoy about your channel because I get to learn with you. You know what I mean?
Awesome. Yeah. I'm glad to hear you say that because, like I said, I think everybody gets mixed reviews, but I do get mixed reviews, yes. So I think that is kind of the objective. I'm learning all this stuff and I'm video blogging it, kind of like like a video library of my quest. And it started off with just me spin. I'm like, I want to make the wheel spin without me spinning it because I was working on levitation, and my first video with magnets was on levitation, and how you could squeeze a disc in between two other discs and have it basically be floating there and be compressed. So it was like really interesting. I never got any motion, but I tried like moving the magnets to like the edge of the magnet on the other disc, like putting it right in the fields and everything. I tried everything. So I moved on to like power and stuff like that. Um, but I'm also limited by, maybe my imagination a little bit, uh, for things like permanent magnet motors. Um, that's another thing that intrigues me. I believe that it is so true, like it can happen to have not need power at all. Uh,
Hmm.
But it still eludes everybody, and pretty much everybody's basically said that can't happen. Um, but I whip out all my magnets every now and then and give it another shot.
You know, I I think Mike Faraday pulled off one where you had the magnets around the disc, but then he made the cool trigger is the magnet has to move back and forth
Yeah,
because I tried this forever. Trust me, I spent 4 days on this thing, driving me nuts. I'm thinking I'm smarter than this. I'm smarter than this magnet, and why is it not working? The field around it's so stiff that getting anything, you know what I mean, to not hit it and stop and then hit it and go, you know what I mean?
Hmm.
It's such a small little thing, but if you move the magnet back and forth, then it starts to go repetitiously, right?
Hmm.
So where instead of the sensor picking up the trigger, the magnet is the trigger.
Yeah.
Sorry. And
But
then
how many magnets were on the wheel?
I think he's got 4 magnets on the wheel, and he's got 1 magnet on the outside on the trigger that goes like
Okay.
that.
Yeah. See, with because he's got the solid state switch that goes back and forth like
Hmm.
this. And is that the one you're talking about? Like,
Yes.
and then you put a magnet on it, or there's magnets on it that will push as because the magnet comes by and pushes it back, and then as it moves on, it falls forward again, and then that little tiny bit on the fall forward like pushes it along.
Yes. He catches it at the right moment, that perfect moment.
Yeah, that is awesome, man. That is so cool.
Yeah, doing that with permanent magnets, I tell you, it's a patience game. And maybe it's just knowing what's going on, but to me, it drives me batty.
Now, did he call it the Howard Johnson, or
Um,
is it not a Howard Johnson?
I'm not sure which one it is. I know there's a specific inventor who does it. Um, try, I'll have to ask him. I know he was in the chat earlier. I'll have to ask him which one he did. Um, but yeah, he was trying to do another person's motor and came across this, and he basically it seemed to me, and that just my opinion, it's the flywheel effect. When you could get something that rotates and you can just add a little energy when it needs it, take it away when it doesn't. You know what I mean? Kind of
Yeah.
that effect, and it gives you that over unity. I want to shout out Ulysses right now. Thank you, man, for the super sticker. I really do appreciate it, brother.
Hey.
Right on. Thank you. Yeah, it's interesting. It might be Mike Johnson. No, I'm thinking it's a different name. I don't know why. But yeah, he was getting that one to go with that. That's the only one of those I've seen, unless they took all the magnets and they angled them. I don't know if you've ever seen that. They take a long cylinder and then they angle the magnets like this around it. And then they do that several times and it makes it rotate where it hits just the right balance.
Okay. I could see that being very possible. Oh, there it is.
There you go. He said, yeah, Howard Johnson, you're right.
Uh,
There's a demo video for that one right there, is what Aaron says. Yeah, I seen the video. I don't know if I'm allowed to play it, so I'll let everybody look that one up. But yeah, they do have some permanent magnet motors. The cool thing is levitation. So if you take a magnetic field in the center and then counter rotate it on the outside of it, and you lift aluminum with it and you use AC, it'll stay in one spot and not move outside the outside parameter.
wow.
So if you
Yeah,
take an
that's
electromagnet and then another one on the outside, counter rotate them. Yeah. It sounds crazy, huh?
no, that would be great if I could make that work. That'd be freaking awesome. Like,
Uh what was his name? Professor oh, I'm gonna butcher this name. Lewowski? Something like that? Luftwaffe? Something like that. I sorry, I'm gonna hate that and destroy his name. His 1950s, I think 50s or 60s, he was creating those things, and he tell you how that worked, how maglev worked, everything, and he'd take these big giant balls, you know what I mean, like that, these big huge balls, and they had aluminum on them, and he'd make them float in the air.
oh wow.
Oh yeah, and they'd spin and everything. Um, anyway, he did that. He also did the ones where you took the pole and you had like a basically a 25-pound weight, and he spun it up with his drill, and he got it to go about 2,500 RPM, and then it would move around like this around him, and the weight would be less, but the centrifugal force would be holding it. So it was really awesome, that guy, man.
Sounds like you had a great understanding of how that works.
Oh, absolutely, absolutely did. Um, Man, there was another one. The physics guy I love to watch, and I tell you I'm horrible with names. Um, but he's got the hair that sticks out like this, and it's all white, and he always tells you physics is his game, and he gets in there, and I love the guy, man. And he goes over there and shows you all different kind of resonances and pipes and everything else and string. Um, that guy's amazing too. Yeah, a lot of people have watched those, man.
Awesome.
Awesome. Yeah, but as far as what you're doing, man, the motors and stuff, I'm like I said, I'm just barely getting into it. So I got the Bedini going, and I got my Renegade going, and then I'm gonna build my own after that.
Awesome.
So
Awesome, man.
we'll take every lesson I learned from every one of those and rebuild something new.
Yeah, that would be great. If you even like want to dabble in what I did, like the electromagnetic in the middle, because not many people do that. But say the problem with that, having the electromagnetic rotor, is you can't hook a meter up to it. You can't, you know, do anything like that with it unless you make a commutator plate.
Well, if you make them Bluetooth, they'll
Oh
give you
yeah,
the
yeah.
signal.
Hey, there we go. Like make them all wireless, completely wireless.
There you go. So shout out Lightspeed right now. He's over there working on a device where he's buying all the parts on Amazon, and it'll read all that stuff. And then he put it into a computer program that he built so that it'll give you all the readouts. So once we get that in house, I'll share it with you, and you can see if it would help you out. Because if you could put a couple of those little things inside there, and
Oh
it
yeah,
just told you that, you'd have a perfect on-screen readout of everything that goes on. Then you can really tinker. You know what I mean?
yeah.
Which capacitor do I change out? You know what I mean? What's the different energies that I get out of it? Where's the frequency go? Man, it would sharpen everything up perfect for you.
It just yeah. And there's probably a place for it like right now, just like anywhere. Uh uh
He says it's
it's analog is it's analog. Very,
yes.
very just trigger strands and MPNs right now.
Well, yeah, I kind of think I'll be honest with you, Papa. Once uh once he's done with that program, and all credit to him because he's doing it, on his own. It's gonna wake up everybody in this whole genre of what we're doing to what's going on. Because if you could build something for say a couple $100, put it on your computer and read everything out and be able to dial systems in, you'll understand the energy better, you'll understand flow pattern better. And if you make a secondary program that shows you the flow through your coil of what you're getting and how much is going where, you know what I mean? And it shows you in 3D rotation, stuff like that, and you're looking at it, that's so much more advantage because he's originally building it for my gravity flyer. So when you put it on there, and so in the intro of that little gravity flyer, but where the spin is, where the field spelled out is, in each layer where the sensor picks them up at, you know what I mean? I
Hmm.
need to tighten all my fields together and get them to, because as soon as you tighten them, they go faster. And the energy flows faster between each one as you tighten them. That was kind of the goal here, so we can get this project finished. So once I see that, it's a total game changer. Now, if I could visually see it, I would be able to do it. You know what I mean?
Hmm.
I'd be able to do that quick, but I can't. I don't know how. So
Yeah, I'm in the same boat as you because the gravity flyer, once it gets in the air, I mean, you're not going to have a bunch of wires hooked to it, right? Are you?
nope.
No, it's going to be exactly. And so you got to have all those the wireless monitoring. Man, dude, that would be so cool. And he's making that for your gravity flyer?
Yeah, so we can test it. So we put all the little sensors around it, and it tells you everything. And he's already got a self correction program. So we were doing some lives and stuff, and he picked up on what I was trying to say on how entropy works and how the energy flows and how they get into the different structures. And he created a program that would actually put all that into account. He says that when he started, he was getting about a 30% result that was good. He's up to 99% on his results. You know what I mean? Through all of his demo stuff to find out that it works. Now it's time to put it into practice and make sure that it's 100% verified. And then he's got the best program ever to fix every one of these things. And it's like a self correction circuit. It tells you, hey, I'm going to need this, or this is where the energy needs to go. And you can find it real fast.
Is it controller style, or is it like do you have an Arduino or
It's like
Raspberry
an
Pi?
Arduino. It's one that's made for this kind of stuff.
Good.
So that the frequencies don't mess it around. You know what I
Okay.
mean?
Yeah.
Especially when you get into something like the Gravity Fly, because there's a ton of frequency that's open air. It likes to wreak
Messes with
havoc on
it.
everything. Oh,
Yeah.
dude, everything.
Everything. Oh man, that could cost you a pretty penny.
I tell you, I got one in here, my Tesla coil now. I did a live show and I EMP'd it twice. So the water acts as a capacitor to it, right? And I turned it on and it didn't really realize it right away. And it held the energy. And there was no light coming out of it. I'm thinking, did I blow my Tesla coil? You know what I mean? But what was going on is the energy was trying to oscillate between the water and my power supply.
Mm.
And as soon as, because it's the thing tries to recorrect the frequencies in both as it does it. Once it did that, all the capacitors filled up and everything and dumped all at once. All the water capacitance, everything. Boom.
Wow.
Completely shut off, right? My computer, my TVs, my air conditioning unit over here,
No
everything
EMP
shut off.
pulse. No
Yeah,
EM
totally.
pulse.
It didn't fry them; it just shut them off, right?
Mm.
So then I go and do it again. You know, smart me. Let me not correct anything and let me try it again, right? So I'm sitting there on a live, and then boom, I hit it again, and then everything's gone,
Oh no.
and I'm going, oh man, I got to stop doing this. So I switched over to my ZVS after that and finished the show. But let me tell you, man, some of these circuits when you get into wireless energy are wild because they like to mess with your phone. They'll turn on different things. They'll search the internet for you. You know what I mean?
Oh man, that little electron's got a bad sense of humor.
Oh yeah, it all does, man. It it all does. I got one last week. I was doing a show on a live, and I got the water to zap me for the first time.
Oh
You
wow.
usually the water's pretty. You put your hands in it, no problem. I'm running 60,000 volts into water, and I don't feel a thing. This
Tap
time
water?
it just into tap water,
Wow.
and this time it got me. The surface of the water when I tried to break it was loaded with energy. I had used a smaller bowl of water instead of the main water thing that I use. And usually when I use a smaller bowl, I'll take in my Rodin coil and it'll change the frequency and lessen the effect on anything that's going on. But this time I didn't use my Rodin coil and it got me. So it was like I was putting my finger down and here's the water surface and you just see got me right there, just like that.
Wow. You could see
And
it?
oh yeah,
Okay.
oh yeah, it jumped up and bit me. I tell you, I
Mm.
got I get shocked more than anybody. So
That
yeah,
that's I like didn't know you could use like the water, normal water. There must have been something else in it, right? I mean, normal water is a resistor, not a
I'm using
conductor.
different energy.
Ah, different energy. Probably a lot more of it too.
So I'm using the center of my Tesla coil, just a rod down it with nothing attached, and it creates an impulse. So it's mostly dielectric fields that are going
Okay.
on. So I'm thinning my magnetism down to nothing, is what I'm doing. But I'm running it cold instead of hot. So I'm using the cold side. So basically, anything that's attached to it acts as a heat source
Mhm.
and pulls the energy to it like a PMP would, right? So that's why I was surprised it got me, because usually it takes a lot more than that. So, like, I'll cut an orange in half and hook a light to one side of the orange and this side to the rod down the center, and then go like this, and you'll see the dielectric field building between them. And it'll turn on the light bulb and make it brighter and less bright. And you can see what dielectric field actually is.
Okay.
So, and it goes through everything. Lead won't stop it. Mineral oil slows it down, but not doesn't stop it. So I don't know, man. That's just my take on stuff. Yeah, I mean, it kind of gets you a
Cool.
little bit.
Yeah, yeah, man. I mean, I didn't. It's kind of shocking me that the tap water's got you, but it's like,
Minerals.
yeah, there's definitely something in there.
You're charged with minerals. Like
Yeah.
sand works beautifully. That's the thing. Put sand in there. If you put this thing into your ground into the water table, and I put sand up above it, you know what I mean? And I put just some water in there. I took a 12-foot by 12-foot pond in my backyard that was 3 inches high of water on top of sand, and lit up light bulbs everywhere.
Wow.
I'm at 12 volts, and I can walk anywhere in a 12-foot by 12-foot pond and light up light bulbs while walking in it.
That's cool.
It, it makes you want to mess with people and put on your Jesus robe and
Yeah.
just.
I'm walking on water and I'm lighting light bulbs.
I don't think I'd ever do it, but I think it's hilarious to think about.
Yeah.
No, I did that, and then you go out, and some of this stuff with a high voltage, it gets purple on the outside of the wire or blue. If you get it in cold, it's in blue. If it's in hot, it's in purple. But when you go out to the cold night, it's like super cold outside. There's dew on the ground, everything. Yeah, you get that. Did you get the same effect?
Well, I mean, no, yeah, this one wouldn't light up. This is like this takes a lot to light up. I don't know exactly like what the filaments are made out of, but I think they're like clothish. It reminds me of a Coleman lantern,
Mm-hmm.
like that stuff that you could light up and it's that material.
Okay, I see him.
Yeah, and I lit this with my with my pickup coil yesterday. I was like, I was like, God, it all came together. It's the first time I've ever seen this light up, and
Nice.
it was really bright. And I was like, I was using my 9 magnet rotor with the 40 millimeter cylindrical magnets in them. So I mean, it's great. Um, with this rotor, uh, I can probably generate 100 volts and maybe 2 amps off of that coil because of
Nice.
how and if the size and strength of the magnets, it depends on what you're doing for what's the better. Like if you're trying to get any kind of induction or electricity from the movement of magnets, you want bigger, stronger magnets.
Okay.
Uh, Yeah, if you're just using a Hall effect sensor to get motion, you can use a little 10 millimeter magnet like that, and it'll be enough to make everything work. It's weird. Um,
But for
but
the amperage, you want the big magnets.
yeah, for the energy you get from the wheel moving, you
Mm-hmm.
want big magnets. Uh, if you're gonna like use your circuitry to move the energy on, from say the battery to the motor through the circuitry to the next motor or to the next whatever it is, then you use your circuitry. Um, I think Bedini, you get off the collector and the diode off the collector, and then the connection to the emitter, and that literally will charge a battery like that. Um, yeah, man, this I'm thrilled about this coil that because it was kind of put together as like three spools that were almost gone, and I rolled the 32 and the 30 together till they
I
were
saw
gone.
that. I
Yeah,
was looking for winding videos and I saw that.
awesome. You saw that. That's great. And then I wrapped 28 around that whole thing for about 5,000 turns. Weighs about 2 pounds. Uh, and it's great. I'm experimenting with the thicker gauges to try and get more amperage.
Hmm.
Um, and these things don't generate a lot of amps. I mean, no matter what you're going to do, they don't. Um, but to get more than what you got the last time, or with a 32 gauge coil, you could get 300 volts with the 32 gauge coil, but you're only going to get maybe 100 milliamps, 20 milliamps of amperage. I
So I got a question for you. Have you ever counted around coils in there for a pickup?
counter round them. No, I haven't. But I could have this time. I could have flipped everything around and counter wound it. That's actually a good idea. I'd probably try that.
Well, here's what I did. I took a Tesla coil and I put another one inside of it, but wrapped the wires the opposite way. What it did was took light bulbs that I couldn't light up and lit them up like daylight. It would take mercury bulbs, it would take LEDs that wouldn't light up. It'd even take incandescent light bulbs that wouldn't light up and light everything up. Somewhere in there, that counter winding gave the amperage field a higher value. So
Okay.
if you did the outside to the right, okay, take an inside coil and put it to the left. And then put your light up to it, you know what I mean? And connect it. See if you can't get that to give you a higher field, because Floyd Sweet did it this way and this way, right? So he had
Mhm.
this one wholly wrapped like this, and then this one wrapped like this. But when
Okay.
we think about it, my Tesla coil went like this on the outside, but the inside went like this.
Hmm.
There's something to do with counter windings that gives you more amps out of something. So if you're desiring more amps, maybe one of those tricks might help you and it doesn't have to be giant or anything like that. Just to put it in the center, maybe as a counterwind core, and give it a shot.
All this counter stuff. I feel like I'm in the right place. I'm making the counter rotator and then the counter winding and then the counter fields and all the counter stuff feels like there's something playing out right now.
Oh, absolutely. Well, we're getting to the heart of it, aren't we? Most of these Avengers, when they did their over Unity devices, I don't know if you noticed this or not, but there are multiple coils. There's no resistors. There are very few diodes, if any, on any of them. Most of them had to do with putting the correct amount of windings to match the frequency between them so that they're exact, so that they pick up on each other. For instance, if you put 4 pickup coils in a system and they have the exact same frequency, and you can match the rotor frequency to that frequency, you'll have a lot more energy because it won't have to resist it so hard. It'll be able to flow a lot faster and be able to pull out the energy much faster. But that's not the way they do things. Like if you took a transformer and matched the transformer on the pole outside,
Hmm.
then you'd get a 99% efficiency. Where right now you're probably only getting 50% efficient. We're using brute force to do it. So if you start thinking about things in that way, then the frequency of what you're building matters. So you just have to find the value of it, right?
Yeah, I found out like I'm bumping into that right now with the counter rotator. You got the three switches, and when you
Mm-hmm.
turn all three of them on, it makes this horrendous like hum. And it's because it's not in sync, I guess. Um, be- uh, I know this much I do know. I know that all 4 drive coils are the same size. Exactly. They're exactly 200 turns apiece of 28 and 20 gauge. They're 5 ounces. And then all the pickup coils are the same size. They're 2,222 turns of 30 gauge, and they weigh 5 ounces as well. So it's weird how I got the number for 5 ounces of 30 gauge and the number for 5 ounces of this. Because when you put them together and you get that proximity transformer going, so like when the drive coil hits and it's that close, the pickup coil is going to pick up on that, and it's going to be a strong boost to the capacitor banks. So having it on will always be better than running it without power, because of that fact. Um, but the magnetic induction, and see, with the remote, like we were talking about this earlier, with the remote, I can get it up to speed, get it going really, really fast, and then cut the power
Hmm.
while it's going really, really fast. And then those magnets will have an opportunity to do what they're designed to do. And I'm maybe 5 minutes or 10 minutes of operation that will taper down to nothing. And that's knowing that relieves all the pressure from around you. Just knowing that it's going to probably without power stop more than likely, you know?
Yeah, you don't keep it going forever.
Yeah, or it'll keep on going forever, even after you turn the power off. It's like, what's going on? Nah, I don't know. We'll have to see. That is a goal though, to like have it kind of power itself, but I'm thinking between 5 and 10 minutes.
Okay.
And I know that you got coast factor, but I'm telling you, this is what I'm saying. With the coast factor, it would coast for a longer period of time than if it was self-running. Okay, when it self-runs, it actually slows it down eventually, faster than it would if it was just coasting. Because I don't know why it happens like that, but it's an observation that I've made that hey, all right. Um I really wanted to go, but I think the next step is to actually have it go at full speed and then cut the power, because you
Hmm.
have to stop it to cut the power right now. So that'd be great to get a little button remote. That'd be awesome.
Yeah. Well, to be honest with you, you want to also pull a bit of merry-go-round effect. So as it's going, you just want to tap it with power when you need it. So one of the ways to do that is to have everything when you cut it, it just fills to the capacitor bank and then drops back as you need it, right? As it feels the rotational rate hits a certain level, you tap it again and it keeps it going. I always say this, you talk about the word create energy. Because we know we're not doing that, we're pulling it in from the environment. The environment is also filled with other things. So it's like a viscosity. We're going through mud. Sometimes you get an easy patch of mud and you slide right through it. And sometimes you get the real nasty stuff and you're not going anywhere. But that's the same way we pull in energy from the environment. So if you could think about it in that way, you need to give it that little tap when it goes through the crud, and you need to let it just coast when it's going through the easy stuff that you slid right through. And
Gotta
then
have control.
there you go. So you can see it in the RPM rate. So as soon as the RPM rate's connected over to your power level and you can give it that little tap, then it'll start to do it automatically. So what happens is over time, you're going to get way more energy out of it than it costs you to tap it every once in a while.
Now I do want to have extended measure of control over the device, but I also want it to be as natural occurring as it can, because I believe the counter rotation is a natural occurrence.
Hmm.
Um, so like if you can set it up so your two parts will spin, they're going to spin in opposite directions when it's on. So if you're spinning it and it's all going in the same direction, you're not on. It's not on. You can start rewiring stuff.
Well, it's building zoning. As soon as you counter rotate, you're building a zone. So it's like a sheath zone. It builds a barrier between the two types of energy. So it builds a common wall, and then it builds the energy on each side of the wall. And then that way it moves faster. So you just get a little energy that goes through, and that's what you're doing. You're driving with. You go to the counter rotation. So it's same thing as what the Rav does. It's like a harmonic as you do it. This is why the sound comes very important when you start doing rotation. One goes one way, second one goes the other way, third one goes the other way. Or you could think about it like this. If this one's going like this, the next one goes like this. Then the next one goes like this. Then the next one does this. So it all counterbalances each other each time you try to do it. But what does it do? It keeps the energy out of phase from one another. And if they're out of phase, they don't mix. If they're in phase, they all mix. And you just have, like you said, blah, right? But if they're out of phase to one another, now they don't mix. Now they're individual fields that self contain themselves and hold in energy. Therefore, the amount of expenditure is gone. The hysteresis is gone. The heat's gone. The slowing down is gone. And if you get each one to line up in the two frequencies to close to each other, then you get something really special.
I'm
Then they
trying.
start.
Sorry.
Go
You,
ahead.
okay. I just wanted to say before I forget that I tried last night 3 different ways to make that a 24-volt counter rotator with two sets of like two circuits at 24 volts, and it wasn't having it. I think the weak spot was the breadboard. Um, but yeah, 24 volts was definitely way too much voltage, and there was a lot of smoke. That's the first time I've seen smoke in a long time.
Nice.
Yeah, it was great, and the lights were all lit up, and everything. It was just way too much energy in the system, and it was saturating everything to the point where it was actually starting to fry stuff.
Oh,
So,
that's not good.
uh, so I'm like, all right, we're gonna drop it down to 12 volts. We're gonna give each circuit basically its own battery. I have a fourth battery in there to keep it balanced. Uh, but that battery is capped and just chilling. So it's like maybe we could find a way to something to do with that. But right now it's just for weight. Uh, and then the last circuit. This is the one that is like questionable above all the other circuits. But I personally will vouch for this to work. It's so all the pickup energy collects in the cap bank, and then from the cap banks that are when it's running, well that circuit's connected to the cap bank. So as faster it goes, the faster it goes.
Mm,
Basically with that.
nice.
So sorry.
No, it's okay. Get it out, man. Why it hits you in the head. You know what I mean? That's what I
Yeah,
try to do.
yeah.
Yeah, that's why I keep a notepad near me in case I hit one of those ideas. I have to write it down fast just in case, you know what I mean, it floats away.
Yeah, man, that floating effect is getting stronger and stronger as the years go on.
I had my first senior moment. I I was driving my car right on a road that I take a million times. Okay, I know exactly where it is. I literally drove past it and then had a moment of, oh my God, where am I?
Yeah.
And I knew the environment. I knew I've driven on this road a million times. I've missed that turn several times. You know what I mean? But this was the senior moment when I looked around and I didn't know where I was. I just simply pulled over and stopped. And I said, something is seriously wrong here. I should know exactly where I am, right? And then, everything instinct kicks in and you just go, okay, we'll follow this road down. And at some point, I'm going to remember something. But it freaked me out, man, for like a couple of weeks. It was like, I can't believe that happened to me. I was just
Yeah.
stressed or something.
I've had a moment like that where it's like I woke up and I'm like I didn't well, I mean, it was out of a dream, but I'm like I had no idea where I was. I didn't know nothing. I couldn't I couldn't pinpoint what was going on for the life of me.
I've done that out of a dream a couple of times. Yeah. That one, yeah. That one gets me. So,
Yeah, it's like you pray that that day never comes when you look in the mirror and you don't know who you're looking at.
yeah, I'm there with you, man. Uh, I don't even know
My
what to do at that point. You know what I
yeah,
mean? Nothing is.
my grandma had a life like that for the last couple years of her life. She had the Alzheimer disease or the Alzheimer's,
Hmm.
and yeah, wow, man, that I when I heard that, I was like, God, I hope that never happens to me because
Yes.
it really is like that. You don't even know who you are.
That's crazy, isn't it?
That I can't even fathom that. Like not knowing, just it. Not only does it not make sense, but it's like you got to feel for people like that are going through that because it's like it sounds like one of the saddest things that could happen to a person.
Yeah, my mother-in-law is getting to that point. She's getting to that point. Once in a while, just kind of, and I don't think she's to the point where she can't remember who she is. It's just her mind goes blank. You know what I mean?
I do.
So, and then everybody, she does things, I guess, autonomously or, you know what I mean, just at out of repetition. But then I don't think she remembers any of it.
Ah, yeah, right.
So, but that's okay, man. She's been a nice lady ever since I've known her, so I'm not worried about that. Just hoping she doesn't have too many more of those moments.
Yeah.
So it's all
So
good.
didn't mean to take a somber turn there, but it was
No,
just
it's all right.
all right.
So where do you want to go with this thing next? You got the counter rotation, you got the Utron. You obviously mastered pulse motors now.
Well, I mean, I like I said, I what I know is not vast, but what I know about what I know is pretty strong. So
Hmm.
um, I've mastered the circuit, and that allows for me to uh, basically put it on any wheel that I desire, and so it becomes versatile in that fashion. Um, yeah. So I mean, and now it's like I gotta like think about maybe learning other circuits as well. Like I think there's this LJB9 or something like that, some circuit like that. I like to learn that circuit. Um,
What is that one supposed to do? Is there a special thing to it?
well, it's just a different way to run the motor. It's a DC circuit, I'm pretty sure. Um, don't know, but PCB. God, I haven't seen heads or tail of him in the last couple of days, but he used to build pulse motors like maybe he still does, like I did,
Hmm.
with this 3D printers and 3D PPM. That's the one.
Okay.
Yeah, he's awesome, man. I don't know if he's still around or not, but I watched him and he inspired me to a couple of my builds actually.
Very cool.
Yeah. I don't know about him though. I haven't he either blocked me or he isn't doing anything right now.
That could be like everybody else, you're waiting on funds to get to the next project.
Right on. I'm definitely in that boat.
No, that's why I'm building all these coils over here because I'm in that boat. You know what I mean?
Yeah. So I was thinking about maybe trying to use some of my, like I was explaining to you earlier about using some of my pulse motors to act as signal generators, and change up the frequency of the energy as it passes through them to see like if the frequency of the energy changes in any way as it goes into the charge battery. So that I mean, maybe I'll get better readings if hook the meter up somewhere else. I don't know. But that I think that it goes into the battery a little bit quicker. Um, but I don't know exactly how much energy is going in there at a time,
Hmm.
going into the battery at a time. It's hard. I don't think I have the right tools to get the exact data I'm looking for.
Well, I'll say this a quick trick. If you're running three separate pulse motors and you want each one of them to be at different speeds, you put a resistor in each one.
Okay.
And by changing the resistance in it, you're going to be able to change the speed of it because you'll change the frequency of it, of the energy going in. So if you take a 10K potentiometer and hook it to each one of them, right? And then you go, okay, I'm set one here on this dial, then this, and then this, right? So what is it? 12 noon 9, you know what I mean, on your clock, and that's where
Right.
you set them. Each one of them will have a frequency. Each one will be just off from the next.
Okay.
That's a pretty simple way of doing it. Another way is you could buy a little module, like it's about this big. I think I have one in here in my drawer. Let me see. I'll just take a look real quick. Um, but you could do that. It's a little frequency generator right here,
Okay.
and it'll give you the duty cycle, and it'll also give you the frequency that you're running at, and you can change each one. And you could do it digitized like this, and that'll control everything in each one of them as the amount of energy that goes into each one of them, or each one that goes back to the battery or to from the battery going out. You could change all that kind of stuff like you want. It's like hooking a frequency generator onto your battery and then
Okay.
running it.
Yeah. So I mean, each motor's rotor has different magnets and different amount of magnets on it. So does that change the frequency at all? Or I mean,
Anytime
without
the if you're talking about the energy pulling out of your pulse motor, anytime you change the speed of it based on whatever magnets you use, yes,
all right, so basically like if I just have different amount of magnets on each wheel, um I could,
change the
you know,
frequency, yes.
change the frequency just running it without control.
Mhm.
So
You're
um
looking at mechanical oscillation, is what you're doing. You're going
yeah.
old school on us.
Yeah, well, I mean, I need to learn how to at least write the language for Arduino or Raspberry Pi or whatever one I decide to use. Um, but I also want to know on the flip side, how to do it in case, my components are all broken and it's post-apocalyptic and there's no store to buy more components at, you know, what
The
am I going
Radio
to do?
Shack.
Yeah. Uh, I gotta, I gotta be able to put it together and have it work without the brain. Um, but I do need to learn that very much.
So you set up three control motors and run the same coils on each one of them, and just change the magnets. And on your oscilloscope, you'll be able to see the frequency, and how it builds out into a sine wave, and then just record each one of them, and then based on that, you could tell exactly what you did. You know what I mean? Each frequency modulation to it, every time it did it, which volts and which amps changed, and you'll be able to have a basically a starting point for everything on it.
Sweet.
It's like a control. Yeah,
Yeah, yeah, and that's science right there. If you don't
absolutely.
have a control factor, you're not doing science.
Yeah.
Um, it's that's how I was, in school. That's how you're taught. But that's what science, almost the definition of science, is to have a control factor uh, over the experiment.
So I have an experiment here that I do. I have a capacitor. I have the power source, and then I have a coil, and I'm just putting energy through the coil to see how fast I can fill the capacitor, right? So what I do is I switch out cores. So I'll have no core. Let's see how fast I can fill the capacitor, right? Then I'll put in the next core. So I put iron in there. I get a better field, you know what I mean? And it fills up the capacitor a little bit faster. Okay. Then I'll start switching it out. I'll put aluminum in there. Then I'll take it out and you can put bismuth in there. Then you take it out, put cobalts in there. So every time you switch it out, your timing is based on how much time it takes to fill the capacitor. So what it does is it gives you a chart, and you can really go through each one of them and see which one is the best core for what you're doing. You could put hollow cores in there. You could put cores with the rods in there, like I showed you earlier. Anything you want, and it'll tell you which one works best for your operation. And you can also do some material science that way. So when you look at your oscilloscope, it's set up to do a magnetic frequency based on iron. Okay, so that's how it's meant to read everything. But if I do that on aluminum, it gives me a very low signal, but my capacitor is telling me something different. My capacitor is telling me it's filling up close to the same rate as my other one. So what's the problem? When you deal in phases of energy, each one of the different materials has a different phase. So instead of them being one hump and then another hump on top of that, another one like that, how they normally try to tell you how phasing works, it's literally looking at a wire of the backside of it like this and seeing a clock. Each one of the pieces on the clock where it goes is a different phase. Each one of those different phases is based on a different piece of material. One's iron, one's copper, one's aluminum, and they have different phases. So when the oscilloscope looks at it, it's not at the right angle to see it. So it looks real low when it's actually a high volume that's going through it of energy. The capacitor is the non-liar. How fast it fills up is telling you the truth of how much energy you're actually getting. It's also telling you the environmental condition where you have less impedance and higher impedance on different cores. It's an interesting way to look at it, man.
Yeah, no, I was thinking, man, you hook all that up at once. Can you combine them on the same wire?
Well, I'm sure if you use multiple cores, yeah.
In phase or out of phase? I mean, in phase. I mean,
Yes.
they keep them. It's wow.
Stack each one of them, yeah. And then you probably get all the lines coming out and you can combine all those.
Yeah, that's amazing. And I think they'd be easier to combine and with the different cores affecting. I'm talking about like hooking all those coils up to different motors, and then have like each all that, and then have it all come together in like one super cap.
Yeah. Well, that's kind of the idea in the end. We're doing all the tracing to find out which core is the best, and then we'll do all the work to find out how to combine them. Then we'll do all the work to see how the magnetic field comes out. Like,
Well, if you got the best, if you find out which one's the best, then the combination experiment would be purely curiosity.
yeah,
Yeah, that would be awesome. I mean, just to see like if like all that energy could come together being different, it's I think it would be great.
yeah. Well, this is why they use different cores. They use ferrite, soft iron. They also use another kind of iron. I can't remember the name of it right now, but it's a very fast switching iron. Okay, so it's a lot better than even soft iron in there. It's even better than the ferrite, and they don't have it in average motors. It's a high end material. But some of these things are composites. They're different type of materials put together for a certain reason. Like say an aluminum bismuth aluminum. Why would you want that set up? The aluminum resists things, but then the bismuth builds eddy currents and magnetic fields fast. So it's a fast acting eddy current machine. So it would spike the amount of energy inside of a core quickly. You know what I mean? Where then the
Yeah,
aluminum would push it out. So
but that's gold, right? We're talking about the same thing here, gold, bismuth, or just
no, just regular bismuth.
okay.
It, if you wanted to use gold, you'd get a rapid rate that goes through it. You wouldn't have a lot of magnetic field to it, but you'd have a ton of energy. Your dielectric would be through the roof. It moves so fast. You know what I mean? That's
Yeah. Well, I mean, like somebody, I believe Daniel, he mentioned making a ceramic out of 3 components. He said gold, bismuth, something, and something else, and then you can levitate on that just from those 3 components being together.
huh.
I forget which one it is, but it sounded like it could have worked, because it was a just
Magic formula. That's what
yeah.
it is. Well,
That's
it's
awesome.
okay. So if you want to magnetize gold, you have to make the core of your electromagnet gold because you need that type of energy running through that type of field in order for the gold to react to it. Otherwise,
Okay.
gold won't react to anything. It'll just throw the energy right through it. It won't be a reaction to it. So just think about that. Material science is if the energy in the earth and you're going through all the different forms of metal as it goes through the earth, then you're getting every one of those, that magnetic field. Like I said, that clock, now you're ticking around the clock to every single one of them. The
Hmm.
reason you can't throw a magnet out in the air and it float is because you have way too many types of energy going on all around us.
And when you combine all those things, what do you got?
You got the right one. But there's some stronger than others. So if you get the main ones, like Daniel will say, then special things happen.
Yeah, I was like, really? I would love to have one of my rotors just floating on like whatever ceramic disc I would make out of that,
Yeah.
or maybe even a pyramid shape. I don't even know what I would do with it. I don't know how I would do that. But I mean, it sounded like I said, really cool. Like, uh,
I think even adding aluminum to what you're doing, there's an eddy current factor that goes on in there that'll make that aluminum and the magnetic field counteract each other,
okay.
or you get a spin out of it.
Oh, just
So
an auto spin, like one of those.
yeah, so I took a bunch of magnets, put it on a plate, right? And I spun the plate, and I just had a plate of just pure aluminum sitting right on top of it, right? So as the magnet spun, the aluminum plate on the top started spinning.
Yeah, yeah.
So, but think of that in an electro in 2 magnets right there for a hover effect. If that's what's going on and the aluminum resists going down to it, then a thick enough piece of aluminum would give you what you're looking for. It's also in AC an anti-gravitational force.
I got you. So,
But you
but you
can
need a
use
thick piece of aluminum then, wouldn't you?
not necessarily. It doesn't have to. You can use a thin one and it'll still rotate it.
Okay.
But then this goes into the double field now. Take counter rotating fields and put it into there. Okay. Now you start to get into something special, something that most people don't ever see. Okay. So you're going to get a DC field with an AC field on the outside, and you're going to converge the two. And when you converge the two, it'll start oscillating back and forth to each other. So you'll pull out a lot more power that way. There's a whole bunch of interesting ways to control energy.
Yeah. I think I'm starting to think that's the point, to find different ways to control it other than let it just run rampant. And that's what I'm doing with my the evolution of the counter rotator is to gain some control. Right now it's kind of, like I said, a wild animal.
You got it to spin. You got it to spin faster. Now it's time to control the beast.
Right. It's because, it will like totally explode with the way it's put together. Like it gets going to a certain RPM and it's just gonna go no fire or smoke or anything. Just all the pieces are gonna go whoosh.
You get old school on it for now and just use a go kart brake. So the old go kart brake, it was a piece of metal that goes over the tire, and you pull the lever, and it pulls the lever onto the tire, and then it'll slow down the rotation of it. So if you put a little lever on your wheel and just barely touch it, it'll act as your hand, and it'll just go against it and slow it down. You put some felt on there, and then you won't ruin any of the PLA that's rotating because it'll go into the felt. You'll create a little heat, but you won't ruin it. So you can go old school on it and do that to shut it down for now
You
instead of
know the
using your
weird thing?
fingers.
I think it's because I don't get to run it very long, but there's no heat problem with this at all. There's no heat anywhere. Like unless the transistor is frying. Like if it stops working and the power's still on and like the base has been fried, the base is tripped, it'll get hot then. Because it's like permanently on. But uh yeah, man, it's a really, as long as it's chirping, it won't get hot. It's um because I guess it's because it's working. When it's actually running, the better it runs, the more it chirps, the less energy is kept in the transistor uh, per chirp. Like it chirps, it goes through. It chirps, it goes through. It chirps, it goes through. If it like chirps and then it doesn't go through, then we get some heat.
There you
And
go. I understand that. Well,
it hurts. It hurts. That is, I don't understand how it can get that hot so fast. But it's like I didn't know it was hot, and I grabbed it and I
oh,
pulled it out, and it's like ah. Yeah, sounds
yeah.
looks like you've done that before.
Oh, yeah. Tons of, yeah. I just did it a couple weeks ago. I went over and go, hey, is this transistor hot? You know what I mean? You just grab it like this. Yeah, oh, yeah, it was. Burnt my fingers.
Yeah. Wow.
Yeah.
So, all right, I'm
No,
on a show people if there's anybody out there
oh, absolutely. Show them the art. Oh, yeah, yeah.
with
Here, let
these.
me put you up on the full screen.
All right, so I do these little paintings. Uh, this one is like my favorite. I call him the green one. This is black light paint. So when you shine a black light on it, it'll be really vibrant. But you can kind of see the little Gumby looking guy right there in there.
That's cool.
And then this one is called Infinity Related. And it's basically an infinity sign and a fertility sign to represent family and unity. Uh, everybody hear that song "Fly Like a G6"? G6, Uh, well, there's your G6. None of it's like. I give myself like 15 minutes, 20 minutes to paint a piece, and oh, this one. You ever hear the green sunset?
No, I've never heard of that.
Yeah, like the green sunset is you can only see it. It was in at World's End, the Pirates of the Caribbean movie, or they
Hmm.
hinted to it. It's like the moment when you could get to that one place he was at.
Oh, yeah, yeah. I remember that one. Okay.
Yeah. That's the whole, it's very like mystical time. Okay. Uh,
Oh, there's one I really like right here. Look at
yeah.
that. I love the blending of the different shades of color.
Yeah, I like it. Like, it's I used a putty knife to do like a lot of things. Anything with a mountain, I'm using a putty knife.
Hmm.
Try and like smear it out. And then I paint like I call it like the ether. Winds of change.
Nice.
So if you can just imagine this kind of blowing in a certain direction.
Kind of like Jupiter.
Yeah, yeah. I got a lot of those kind of ones. But yeah, I was doing the art like a long time before I was doing the pulse motor stuff, and then I just got hooked on the pulse motor stuff. But I think I'm gonna incorporate painting into what I do on Papa Balls, Papa Papa Balls,
Papa Ball. Love it. Oh,
Papa. Gonna incorporate like some artwork into the whole Papa Bale thing.
nice. Well, hopefully that editing gets you close to that. You could do slideshows and stuff like that. That'd be cool.
Yeah, yeah. Thank you for that, though. That's gonna help me out a lot.
Oh yeah, I can't wait to see some of it, man. I love art. So I used to draw, man, a lot when I was younger, and then I gave up on it after a while. I mean, doing other things and getting into other hobbies, but I used to do that quite a bit.
Yeah, yeah, man. Art is it's a great release. It focuses your mind. It's good. Yeah, the first yeah, I draw too. And the first drawing that I did was of a naked girl. I got suspended for it.
Well, what else are you gonna draw when you're a kid? I mean, you're thinking about 24/7.
And I mean like what all the faculty had to say about it was like,
Good job.
yeah,
So you drew the picture real good, so they gave you a good job. I love it. Oh
oh,
man,
yeah, it was
yeah, I
yeah.
like the principle of art on how you focus on things and how you distinguish different lines from one another and why they're there. And I try to apply that to everything that I do.
Okay.
So if I build something, I like every wire to look perfect. I want every coil to be in the right place. You know what I mean? Just like it's an art piece, just like if I'm drawing it. You know what I mean? I want that line as straight as possible. Just crazy little things like that. You know what I mean? It's like little Legos building one on top of the other.
That's awesome. It's taking pride in what you do. It's like there's a certain level of pride that you got to take in what you do. I haven't like it's not really permanent like style yet because I haven't really decided, exactly where I want to like what basket I want to put my eggs in right now. Uh, but I'll probably come up. I might do a replication or two in the future. I'm kind of just doing a 180 with my whole abrasiveness towards like, um, you know, because I wanted it to be me. I wanted it to be me. I wanted it to be mine. I wanted it to be different. I wanted it to be, um, you know, what do you call it? I'm losing. I'm losing it. I'm losing it. And it's going to be like one of those monumental Rocky Balboa speeches.
Oh, nice. You want it to be authentic.
Yeah.
There you go.
Yeah, that's it. I wanted it to be not I want when for the replications, I want it to be very authentic. Um, I want it to be from the book, a schematic, kind of like what you did with the Bedini motor.
Yeah.
Yeah, like I don't know if I'd necessarily do that one because I got limited. Like I don't have a garage, like I wouldn't be able to. But like maybe a Newman motor.
Okay. I've heard of those.
Yeah, like a big cylindrical coil, and then the little magnet goes in the middle, or the big magnet, whatever. I could see maybe doing one of those because of it's smaller. But I have 2 bike wheels. I mean, I'm ready to do it. They're not. This is the problem with it, though. They're not aluminum.
Oh, so you're gonna get magnetics in it? Yeah.
Yeah, it's going to end up being one solid magnetic field.
Well, it
I've got to
depends on
get a new wheel.
if you're running neodymiums, that part wouldn't matter. If you're running the ceramic ones, is when the aluminum matters.
Okay. Yeah, then it doesn't matter. I'd probably be running Neos.
Yeah, because the neos overpower everything.
Right.
The other ones are like a subtle tap. Is what the other ceramic magnets are. So different ways to look at it altogether.
Yeah.
I looked on the thing for what was it, Facebook Marketplace, and I found the rims for free.
Ah, good for you.
Found me a set of aluminum rims, and then because sometimes they just sit out and all the metal bolts will get rusted on the brakes, and they can't get them off, and so they'd have to drill them out and make the rotor useless. So they just give the rim away, and I go, well, that doesn't matter for me. I was going to just cut it off anyway. So no harm, no foul. I could care less.
What mechanism did you use as an axle for the Bedini motor? It's not the original bolt.
Original bolt's garbage these days. It's this little thin thing. Yeah. Well, that's the part I'm at right now, and I figured out something very simple and something very stupid, but very true. I do not need the inside bearings at all.
Okay.
I simply needed skateboard bearings, and I needed an all thread that goes through all of them. That's as simple as it gets. I don't need the axle. I don't need the bearings. The shaft on the inside is a big enough diameter where it wouldn't matter. I simply need washers that'll press into the hole. You know what I mean? Mm-hmm. So I just take the little round ones that are on the outside and drill them out, put the shaft all the way through it, lock it in with lock nuts. The center stays completely tight. If it doesn't, then I make a PLA piece that goes on top of that little wheel thing that goes in there for your brake. Okay. And I can lock it in right there. And then I just use a all thread to go through it and run it right through a pair of bearings on the outside. That way I can use a shaft on the outside to do whatever I want with it. But that was a simple answer.
Yeah.
I mean, you don't need it. You don't need the mechanism that's inside of it. It's redundancy.
You created your own mechanism.
Yeah.
That's kind of what I was getting at. Thank you for filling in the blank there.
Yeah.
Because I saw it looked like a little wooden dowel. Did you use wood? Or
I just used a piece of wire. And I go, because that part I hadn't finished yet. And I'm going, well, it works. You know what I mean? I could leave it. But then I'm missing what Bedini said. He said there's 25% rotational energy that you get out of it by using the fan. And right now I'm not using any of it. So I need to have some type of fan or some kind of disc on the outside in order to give me that extra energy. Mm-hmm. And that's the flywheel effect.
So you want the flywheel or a fan to be hooked up to the motor.
Mm-hmm.
Yeah.
So it acts as my merry-go-round.
Which one are you gonna, or do you want to do more like a flywheel or the fan?
The flywheel.
Yeah. I mean, that's what I would do. I mean, it's a lot easier in my mind. You have to buy a fan with the proper boring, to really be. I mean, you could print one, but I don't think it'd be anywhere near as good as one you could get with a proper boring.
Yeah, well,
I don't know though.
Here's my thought on it. I'm just going to make PLA into the inside so I can keep it lightweight. On the outside, I'm going to take one of those things that you have on your table that rotates your food.
Lazy Susan.
There you go. One of those little rings, and they make them in aluminum, and I have very big ones like this, right? I'm going to take one of those and just bolt it to the PLA. So I have lightweight in the center, real heavy on the outside, and now I'm going to create rotation with it. So I'm going to actually put magnets on mine, just like I did my Bedini, and run another coil under it.
All right.
And I'm going to
Yeah.
pull a secondary effect out of this thing. I was telling you earlier, and I'll tell everybody now, the problem with getting over unity is you can't go 1-to-1. Everybody fails. They're getting 90%. You need a 1-to-2, 1-to-3, 1-to-4 ratio in order to pull over unity, but you need those ratios to not slow down the effect. So the best thing that you could do is use copper and aluminum and put it to a capacitor. Run magnets and just run it as a generator. All that's extra energy that goes into the things with very little slowdown or impedance to it. And you get over unity. It's what you can build out from that shaft to give you extra energy. That's as simple as it gets. Then there's no way that they can refute it because you have individual, you know you're going to be around 90%. Then you can get the next 20 to 30% out of those.
I actually made a wind turbine, 2 wind turbines that can function also as water turbines.
Okay?
So they're basically just big wheels that made out of fins, basically, and then they're encased in 2, discs, so that you can run water through it, you can run wind through it, and so like you get the wind. See, what I use is a shop vac in reverse to demonstrate. Oh my god, this thing got going so fast, dude. Like I don't know. It was fun, it was childish, and it may pan out to be something actually if but you need a lot of wind and a lot of water. You just it what am I getting at? You got your bearings, right? And you want something to spin.
Mm-hmm.
And if you've ever seen something that can spin, 20,000 RPMs, and then you look at what I'm doing and it spins 1,000 RPMs, you can tell the difference in what it is. It's a balance, it's size, um, the components. I mean, I'm on a 10 millimeter shaft. I mean, is that even ever going to work? I mean, to get, I don't know. I know that on the 1/4 inch shaft, my rotor, I got so fast. It is so fast. It's so heavy and it's so fast. And it's got the big magnets on it and everything like that. I got the one rotor that like levitates itself on a magnet, so it uses the magnets in it to levitate it on a donut magnet. Wow. And I'm just thinking back to like so many years. Like it feels like so many years, but it's only been like 3. I mean that's a long time to be involved with something. 3 years. That's a
Oh, yes.
commitment. That's a
Oh, it
commitment
is a
right there.
commitment.
Yeah. um
Well, I'm right there with you. I haven't been doing a lot of this stuff to show everybody for, I don't even think it's been 3 years. It might be by now. But yeah, kind of about the same amount of time. You know what I mean? Playing with Tesla coils, high voltage, all kinds of stuff. Yeah.
So who got you involved? Was it Sean?
No, I actually did it before Sean.
Okay.
Uh, Sean helped me smooth out my Tesla coil without question. Um, is how I met Sean because I was setting him on fire and he was laughing and he said, I can help you. And he helped me out with it and fixed it, is what he did because Sean's completely brilliant. Um, but no, it was just high voltage. I saw somebody take a DC flyback and make sparks, and I thought, hey, I like sparks. You know what I mean? Let me try that. And then I go, okay, they do all these anti gravity devices. I said, let me try my own. And I just started building the gravity flyer and getting into it, and it used every one of these components, and I'm all yes, every one I wanted to learn that's on my bucket list. I'm now checking them off as I go. You know what I mean? So it was a neat little project that worked out great for me.
Yeah, yeah. The gravity flyer is interesting. I think I seen where like the from the top disc there was like a field that went down and around, not all the way down like this, but like down to the middle disc,
Hmm.
all the way around, and it was like plasma field. It was a
Yeah, I
I
did
remember
that.
seeing that video. Yeah.
That
That was
was
awesome.
the beautiful look, wasn't it?
Yeah. And so that's the bubble you're talking about, right? Kinda?
It's kind of like that. If you can imagine what your dielectric looks like, that's what you're looking at. So it was just in a voltage where it was way too high and non-usable. But if you wanted to imagine what it would actually look like, that's what it is. Yeah.
Okay. So I mean, would it be like a pink bubble around me, or would the color maybe be invisible if it went all the way
Oh,
around?
you wouldn't see any of it. Yeah.
Okay.
Yeah. Oh, trust me. If it was pink or any color, Papa, we'd be done already. Okay. I- If this stuff built out in colors and I could see it, it'd be game over. I would have already had it done. It's
Yeah.
the hard part is you can't see any of it.
So you don't know, but you do know. I mean, there's indications, right, that it's working.
Yeah, well, like I could put a light out there and light it up, and then I can control the tester coil field or the high voltage field and get it going back and forth and see which where each one is in the open air.
Hmm.
But getting those together and squashed is a different story. So you could put them this far apart, you know what I mean, and distinguish the two. As soon as you get in here, they kind of start meshing. As soon as they get to here, you're overvolting the disc, and it'll start to light up and put sparks everywhere.
Now, see, could I suggest maybe using an alloy for
Yeah.
your discs, um, instead of maybe a pure aluminum, just to maybe get multiple effects.
What's the alloy?
I Me, I don't know. You probably know better, but like the one that Daniel was talking about with the gold bismuth and the other two components, make a disc made out of that. Um, I think, I'm not sure, but since we're talking about like counter rotating fields and different frequencies, you already have your counter rotating field because you got the one motor on the bottom and the one on the top.
Mm-hmm.
Uh, but yeah, maybe I'm I don't know what it would be, but I mean, if you're like, and you haven't done much work on that in a while, have you? Or have you just off screen?
I do it off screen.
Okay.
I get a lot of people. You talk about critics. I get a lot of those.
Oh,
So there's a lot of people that tell me a lot of things about this thing. Okay.
okay.
So it's sometimes it's discouraging because you get a lot of positive comments and then you get a couple of haters that just come in to tell you it's on strings or it'll never work or why are you playing with that? It'll never do anything.
Right.
And it's like, okay, that's all great, but I'm still going to do it. So you're just kind of trying to discourage me and I don't like it. So some of the stuff I just do off camera, like I bought new discs for it. Um, I've changed some of the stuff. I've used other things to change the capacitor in the center of it. Uh, I've done a lot of different work that I just haven't shown lately, and it all mechanically works beautifully. Um, but yeah, I just kind of avoid those people until I'm ready because I got other things they can watch.
I remember what I was going to say in context to changing the disc is that you would get multiple frequencies off of the disc,
Mhm.
if it was an alloy,
Yeah,
and not a super like mixed together really well alloy, but maybe like an alloy that is more polka dotted or calico like.
yeah, that would work. I
I don't.
I've been trying forever to find a flat piece of bismuth, 16 inches in diameter. That's only like a eighth inch thick. And if I can find that, then I'm going to sandwich it between two pieces of aluminum, and that way I can get my eddy current way up.
Heck yeah.
So
Okay.
that's kind of one of the things I was kind of in the back of my mind thinking the same thing. I want those levels to go up because I want them to increase in what I'm trying to do, because it's already building the bubble on the outside. I don't have to worry about that. I just my eddy current. I don't think that the fields are combined right to get it.
And I think that you're on to something a lot greater than just, lifting that thing off the ground. That's going to be the first step. And then when it disappears, you're going to understand that you've now not only created lift, but your bubble is a portal through another dimension.
Oh man, wouldn't I think Joe's gonna have a field day with that one. He keeps telling me going into a different dimension, and I'll have first hand accounting for it.
Oh wow. Yeah. I thought that was pretty good.
Oh yeah. Well,
I mean, and what if it happens? I mean, because you've now got your gravity flyer in its isolated environment, right?
mhm.
Um, yeah, that environment might be quasi linked to just a totally different part of space.
No, we're creating a time dilation field around it. That's for sure. I've already mapped that one out.
I
So,
think I'm getting a little bit of that with my pulse motor, actually, just a small amount. But I mean,
mhm.
I can kind of tell, and like I feel like I'm floating, and then everything kind of like starts looking like it's moving a little bit slower. But I get that tingly like levitation, floaty feeling. So I think I do like experience some of that.
Hmm. Very cool.
Yeah, well, or it could be some health issue. I don't know.
We read it all wrong, man. Just got gas or something. You just floating. I love it, man. I love it.
Awesome.
Oh no, but I think you're right, man, and I probably should show it more. I just I gotten to the point with it, man, where I did it for like a year and a half, and I'm trying to just show what's going on and tell people what's going on, and then the haters get to you after a while, and no matter how good a system's work you do on it, there's always somebody that has to say something that's stupid, and I just kind of try to avoid that every once in a while because I get enough grief for saying the wrong word or saying something inappropriate, or I like to have humor in my day. You know what I mean? So I like to say something that's funny or make funny videos, and then, oh my God, they're not super scientific. And then people yell at me for that one too. So, yeah, I don't know. It's kind of discouraging. I guess it's just YouTube chatter, but it gets you after a while.
No, I think there are literally people out there paid to like troll you. There are people paid to just watch your videos. People get paid to do this, and because I've looked at their profiles,
Hmm.
3 subscribers, no videos. They're paid to talk smack. That's what they do. Um, but I've had them come after me a lot. I've heard my counter rotator, everything from garbage to garbage disposal. You know, uh,
That's what they're telling you it is.
a lot of. Well, I mean, like the one video, I've got like I think over 100 comments, and it's like a lot of them are like, what is this? This is garbage. There's no what's when they come after you, like, what's the purpose? You
Oh,
know, it's like, oh my god, I don't know. You caught me off guard. I got to think of like what the purpose is, because I don't need to. Right now, I don't need to have a purpose, but I need to figure that out.
oh, I'm there with you.
Yeah. But I
My,
tell
my,
them, right.
no, I was just gonna say my favorite comment watching you live was when you told that guy you need to wash your mouth out with soap. He said some kind of cuss word to you, and you're like, should wash your mouth out with soap. And it's just sort of, I fell out of my chair laughing.
Well, at least it wasn't like you beep 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 beep. Like
Yeah,
all the words under the sun that aren't good. Those
I,
four-letter words.
I'm guilty of that once in a while.
Yeah. So I'm like, a buddy of mine came on to one of my streams, and I'm like, uh, I'm sorry, I was ranting. I guess that's what I said. And he's like, "Go, man, rant. I don't care, rant, rant." Rant. And I'm like, I'm not gonna unload like that, man. YouTube's gonna kick me off. They're gonna be like, you can't be here anymore. And I know
No,
there's like lots of videos out there with lots of cussing in it, but that's not what I do. And I guess if I checked all the boxes and stuff, I could do it, but I don't like it.
no. Well, I don't cuss in my regular videos, man. I do it on live. I am guilty of that. Um, but on my regular videos, I don't try to curse. Not unless I'm shocked and it catches me totally off guard.
Right.
You
I mean,
mean,
there's no reason to cuss on your videos, I don't think. Um, because you're in
no,
totally controlled environment, basically. Uh, but yeah, like on lives, like if you just got done explaining something to a T, and then somebody comes in and asks you, and you got to realize that people are coming and going all the time, though. And then they ask you very specifically about just what you got done explaining. And it's like, oh, all right, I'll do it again one more time. But after the fifth time it like happens, you're like, oh man, maybe I should just have like a robot do it or something like that.
yeah, I'm there with you. I'm 100% there with you. Oh man. Hey, you know what?
Mhm.
Um, it's been a couple hours, and I want to get this out there for everybody for tomorrow. Um, we did another. Did you get to watch the Resident Arc Vortex that Sean does the Rav
Yeah.
the the video they did last time?
The most recent one,
Yeah.
I think I did watch a lot of that. Yes.
So we made a second one. We're doing a series on it,
Okay.
and the second one it's coming on tomorrow night. I put a premiere on it. I'm trying to get better at this so that kind of like you. I mean, in the editing booth a lot, working on it, trying to get angles and camera things and all the positioning right. So we put out a second video. Excuse me, it's coming out tomorrow at 5 o'clock Pacific Standard Time on my channel. So it'll be out, and I'm trying to get to a weekly series, but so far it's going to be every 2 weeks.
Oh, that's awesome, man. And you're getting the Rav out there. It needs some attention. Like I know that to me it's big because it's inherent in nature. A lot of what's going on with the Rav, like all the way to the universal level.
Mm-hmm.
So I think it's quantumized and it's quantumized. So like from the universe to the experiment, it kind of mimics itself through all the different levels.
Yeah. Well, what we saw inside of it was just amazing because we thought there was something was going on and it wasn't, and we just verified it. It won't come out for another couple of episodes on this, but we went to the center of this thing, and initially it shows up and there's dots on the inside. And
I saw that picture. I'm sorry, I have to cut you off just real quick
go ahead.
because I saw something like the inside of the Rav floating in the sky above my daughter's school. And I'm like, and it was nighttime. So I'm like, that's a helicopter. And but I'm like, no, it's got my attention, and I'm watching it, right?
Mm-hmm.
But I noticed that it had a large orange ball in the center, and then it had four white balls surrounding it, but they were moving in a fashion that there could be four dark balls also. Uh, and I was just like, I looked up. I'm like, oh my god, that there's no way, there's no way, because it started moving,
Mm-hmm.
and it was making movements that there was no pitching, no yawing, stopping on a dime and going in the other direction. And that is not a craft that we know about. Like as a species, like it's not an airplane, it's not a helicopter. I mean, helicopter would have been the closest thing, but even with a helicopter, you got pitching and yawing when there's going to
Mm-hmm.
be a turn. It's kind of circular. It's not this, and it was going so slow. That was the other thing, man. It was going so slow that there's no way. It's just no way. Maybe because of the speed, the helicopter could do that, but I don't know.
No, usually when it does that, you got something special going on. Just so you know, a couple of the things that the RAF taught us, this is going to sound insane, but it's 100% true. Once the fields go into interaction with each other, it goes silent. All the sound, the high voltage sound, all the chirping, all of it's gone. There's no sound. It, it's
Okay.
blocking all the sound waves from going out of it with the outside sheath layer.
Oh wow.
It also puts off glimmers. So you'll start to see things in the sky all around it, little orbs, all the way around this thing. It's a trip. It'll show up on your wall behind you. Okay. Some of the things this thing does, rainbows, it shows you plasma being built out. It shows you the inside core of what's in it. And when you do the artwork on it, like you put out the balls, it's literally the symbol for an atom.
Yeah.
It's insanity what we're seeing in this thing, and everything from how the universe works, how the solar system works, how the down to the micro, how an atom works. It's showing you all of it. It's one of the most fascinating things I've ever seen in my life.
The most weirdest thing I've ever heard somebody put forth is that the universe is an atom. Like if you're thinking about quantumization, uh, like correlations, I would call it quantum correlations. So it's like this little one down here relates to this big one up here, but
Mm-hmm.
how? How does it relate? And I think the schematic that you're drawing with the atom uh, is what the message is. Like across the board. um,
No, I agree with you 100% on that. And that's the beauty of what we're doing because they based all the analysis on space on plasma physics. So if we're taking plasma physics and we're now showing every little thing about it, now you can really see it and understand it. So it's given so many insights to what things actually are. It's like the perfect learning tool.
the Lazy Susan one that he just did recently, or the where the plasmoid was on the thing spinning around the cathode or whatever was in
Uh
this.
huh.
Man, that was great. The little ball and the plasma lightning bolt, then it just kind of snaked around it. It was cool.
I got one for you. I haven't put it out yet, and I've kind of been waiting. And I'll show you this from Sean, and it's so interesting. Give me just a second. Let me make sure it plays real quick.
Because I was there for the ghost worm. Like,
Oh, the ghost worm is awesome.
yeah. I'm like, what? Wow, okay. What is that?
I'll let it play through and you can see it.
Wow. So this is all building up, right?
Mm-hmm.
Okay.
It looks like high voltage in a bubble, right?
It does.
Okay. So there's something here I need to point out because it looks like nothing's going on. And it's just like regular plasma, right? Like right there. See plasma, cool purple, more cool. Now, right there, you start to see it. Look up and back
Yeah, I see.
on the wall.
Yep.
So you see it building out there. It's also going to build out inside the ball in 2 spots. So now look at it. You're getting a reflection inside the glass bubble. You're also getting it on the wall. That's the same dot, all 3 of those dots.
Mm-hmm.
And then you start to see now everything that you see in the camera effect starts to happen on the wall now. It's lensing the light. So when I say lensing, it means it's hitting a curved surface and it's focusing it straight through like a laser beam.
Okay.
And it's
Or
shooting it.
concave.
Yeah.
Okay.
So it's shooting it on the back wall. Now you see all those little dots and lights and everything on there.
Yeah.
It's when, and then you see it also reflecting on the inside of the ball itself. So it's one of the most interesting things I've ever seen in one of these. And you kind of have to watch for all of it when it's going on. And you'll see it play out in the background. You can even see, you see a high voltage plasma above it.
Mm-hmm.
It's even showing that in a mirror. It's like a mirror inside of a mirror inside of a mirror, like a hollow mirrors.
Yeah.
It,
That's awesome.
so what happens if you actually put mirror instead of the ball itself being clear? If you put mirrors inside, it becomes a prism. Or if you put quartz there, it becomes a prism. It's going to show the light reflecting through every single side of it. That's why it was special. This explains Joe's rock. When he put the crystal on there, why the light was going everywhere. Well, this is why, because it became a prism. It's one of the coolest things ever.
Yeah, man, that looks neat.
You have to slow it down and see what's going on to see it. Normally, things don't do this. You're not able to see all this stuff. Just thought it was interesting.
Yeah.
See, it clearly goes away, it comes back. You've got like a whole solar system going on inside there, man.
Mm-hmm.
Like, look at behind it. It literally looks like a solar system came out of nowhere on a dark wall. So, I just thought I'd show that to you. I think that whole thing Sean does is absolutely brilliant.
Yeah, that's awesome, man. I mean, I look, I think to myself, where does he come up with half of this stuff to do? It's like, but it's cool. I mean, it's really cool. And I don't, I ask myself that. I'm like, what drove him to choose? And I think it's because of the qualities of the material that he's using are scientifically linked to plasma. But I think he does a lot of stuff just off the whim of his, like he comes up with a lot of this stuff. That's awesome.
Yeah. Yeah, he comes up with it and then he shows it. And like you said, the materials are so good that we get to see everything in like high definition.
Yeah, God, man, that's awesome. And that it's like at a high frame rate enough that you can actually get in there and see what's going on. That's
Can't wait to put that one in slow motion.
yeah, high quality camera job there.
Yeah. No, Sean's awesome, man. Like I said, when I first started frying my Tesla coil, it was right there. Let me help you fix it. He was working on the same problem with his, and he was way ahead of me on it. That was for sure. The actual coil you see one behind me, that was a design Sean and I came up with together and working a collaborative effort to get that thing done just to run the ZVS so that you could put it on it and run it perfect every time.
Now, is the
And
ZVS a standard circuit for running a Tesla coil?
God, no.
That's what I thought. See, all this stuff like is like it's a grandmaster like coming up with the stuff. You know what I'm saying?
This is something I think, what was it, 6 years ago or 7 years ago, they came up with. Well, it oscillates, so you should be able to use it on a Tesla coil. Nobody could figure it out. And then two guys got together and worked it out and put a capacitor and changed capacitors to a high frequency capacitor. And they were able to do it, but they never quite said the coil size or anything like that, right? So Sean and I got together and worked on it. We've got the perfect coil size for what was going on there. And we worked through every one of the little problems, where the field hit, where we wanted to be, where the oscillation was, which capacitors to use in it, all of it. With that exact coil, runs beautifully. It's the most reliable machine ever. And then Ian comes along and says, "Hey, I got this cat bag from Master Eva over here." You know what I mean? And then we go, "All right." So I put it over there to it. Oh, tuning ZVS become easy. Just flipping a switch here and there, and then you're in tune perfectly with it. You know what I mean? It's so much easier. And I'm just going, now we have something that's worthy of testing all the time that can be used 24/7 without issue. And you can leave it on long periods of time. I don't know how familiar you are with Tesla coils, but they used to be the internet. Your transistor runs out in like 2 minutes if you're lucky. And if you're unlucky, you get 2 seconds. And then the light bulb, goes out and you're done. You have to replace it. Or they put 10 of them in there and they all still fry. Well, I'm running massive amounts of power through mine, and they never fry. So as long as you know how to take care of them, they work great all the time. So it was
Yeah,
one of
that's what
those.
I saw. The transistors can last like years if you just, you know, do the proper, safety precautions, even if it's just one thing, or making sure everything's plugged in, you know, all the way.
Mm-hmm.
But how do you do it?
I went and researched all of the transistors until I came up with the perfect one.
Okay.
And it's a mix of voltage and amperage and heat. And I learned where the limits are of it, how to cool it properly. My Slayer exciter runs at 40 volts all day. My PNP, it's reverse of everybody else's. It's unique in itself. Runs at 40 volts, 8 amps, no problem. And I get a 5 to 6 foot field out of it, depending on the air in the room.
Mm-hmm.
And it's just a monster circuit. It'll mess with everything in your room. And then we got the ZVS, which I can tune into any frequency I want, basically. And I got, like, the coil behind me. There's 4 different frequencies in that one. I have a tall, skinny one. There's 6 different frequencies in that one. Every one of them in resonance based on the capacitor. What is that sound? What the
Sounds
heck?
like a hurricane out there. I'm just kidding.
Yeah. Is that outside? Oh, wow. Okay. Something's going on.
Yeah, I was like, what? I was like, what is that?
Whoa.
You're freaking. You look like you're freaking out because you don't know what it is.
I don't know what it is at all. I'm thinking it's my mic and it might be outside.
Well,
I
that
got,
sounded like a trash can being pulled in.
oh, maybe it was. I don't know. Yeah, well, it didn't sound good. I agree with all you guys there. Huh.
Yeah.
Wow. All
Because
right.
it did stop though. So
Yeah, thankfully.
yeah.
Well, I'm going to die online because something's blowing up at my house.
like reach you right through the screen, be like, ah, I'm taking all of you with me. That's all.
Yeah. Oh, that's bad.
Yeah.
Yeah. You know, today was a holiday.
Which one?
I have no idea. I just know that everything started closing around me. I went. I
Yeah.
went. I went to
My
go mail
kids.
packages out, and they said, we're not here today. I'm like, what? What do you mean you're not here today?
It's like
And then
Martin Luther King Day. No.
um, I have no idea. It's some holiday of some sort, and yeah,
No, it's not that. It's I don't know what holiday it is, but my kids were off school today. So
President's Day. Is that it?
President.
Yeah.
Not
Well,
sure.
that's what I get for not being in school for a long time. Yeah. So there went my morning this morning. I was out ready to do deliveries for packages and stuff. I got them all boxed up, and I'm all excited. You know what I mean? Get over there, and the place is closed. So, oh well, ship them out tomorrow. Back to normal.
So how is it living in Cali?
In California,
Yeah.
it's nice, man. Mostly sunny. Today's a rainy day for once. We get those like what maybe 10, 20 times a month or excuse me, a year.
Oh wow.
It's
So
barely ever rains out here.
is
Usually
the
sunny,
temperature moderate?
about 75 degrees.
That's hot. Okay, that's hot. No, it's
Well,
not. It's
not
moderate.
necessarily. It could get up into the 90s out here,
Yeah.
but we're close to the beach, so we're getting a little cool air off the beach. You know what I mean? Not a
Hmm.
lot like they do on the beach, but you know what I mean? It's not as bad as Arizona where you go outside and your taillights are melting.
Right.
You, you know what I mean? We don't have that, but
Not 120 degrees, you know, sweltering heat. But that's cool, man. I mean, because California is definitely a much more mild temperature wise than Michigan.
Michigan's cold.
Yeah, Michigan's definitely got some chill. I lived up in how there's an upper peninsula and a lower peninsula.
Mm-hmm.
The bunny ears in the upper peninsula. That's where I used to live.
Oh wow! So you,
So the winters up there, literally, you got 600, 700 inches of snow on a yearly basis altogether. It was sick. It was sick. I mean, when we first got up there, I drove up there my first time. It was in the winter with my mom, and we're driving, and the snow starts falling. We get to the UP, and it's pitch black. The snow is coming down, like, and the only other car on the road was the plow. And so we drove up there, and the plow like guided us the whole way because they knew that if he like turned off or went and did what he was supposed to do, that we were going to get stranded
yeah.
because that's how fast the snow was coming down. Um, but yeah, man, my mom was talking to that at the night about to a friend, and she goes, "Well, yeah, why don't you think there weren't any other cars on the road?" Because I mean, the people in the UP know that was a day that you did not go out.
Mm, wow, that's crazy. Yeah, I can't live in that much snow, man. That would mess with me. I got a bunch of
Hey,
screws and plates in my back, and as soon as it gets cold, it starts to hurt.
oh man, my brother had a back surgery as well.
Yeah,
Yeah,
he probably hates the cold.
yeah, he hates the cold, and he hated that they had actually fused. They fused, so he's in pain.
Oh yeah, yeah. There's no good way to say that. The surgery sucks.
Yeah.
So
Now for a futuristic, just real quick, I see humanity going three ways.
okay,
You got humans, 100%. You got cyborg,
Oh.
And then you've got robot, which is, has a person's consciousness slash soul in it. And those are going to be our three venues to move forward, and they're all going to end up leading to the same place. So right now, and it's going to branch out, and then probably I don't know how many years into the future, it's all going to come back together. And this is a cycle that has been going on for a long time. And I know it sounds like real, cyberpunk 2077 and crap, but I mean, this
Mhm.
is for real. Um, we're already starting implants. Neuralink is a big implant that's going to, guide the future. Uh, uh, Maybe not the whole shebang, but it's going to be part of the future.
Mhm.
Um, so with that being said, I really think I'm going to stick with the human part of the whole deal here, even though immediately that seems like the benefits of becoming a cyborg or maybe having your consciousness put into a robot might seem like the better uh, path to longevity or whatever you're going for. But you know, I don't know if that's the truth.
Well, have you ever seen the Keanu Reeves movie that had to deal with the consciousness? And his family had passed in a car accident with him there. And he put all of their consciousness into new bodies. He basically grew them a new body and put their consciousness in there. And then by the end of the movie, he put his consciousness, half of it or whatever time period it was at that point, into a robot, and the other part he kept.
I haven't seen it, but it sounds like a really awesome movie.
Oh, it was. I can't remember the name. Again, the names I'm terrible at.
There's this Jude Law movie where like every body part you had a scannable on it,
Hmm.
and like you had to like pay for it or they take it back.
Repo Man.
Is that it?
That's it.
Jude Law, Repo
Hmm.
Man. Okay, yeah, that's the one where he like they cut each other open and they're like scanning the body parts. And
Yeah, the
oh my,
Repo Man goes out, cuts the body part out, and then scans it and takes it with him, regardless of what it is, and you're left there to die
oh wow,
if you don't
yeah,
pay your bill. Yeah.
yeah. That's the plot. That's
Hmm.
definitely the plot. Um, wow. Okay, Repo Man. I'll look that up. I haven't seen it in like 15 years, but I remember it vividly.
Oh yeah, it was a great movie.
Yeah.
I remember watching that one. That was good. Yeah. So humanity, if we figure out the longevity of our lifespan, would be a good one. I think some people would go cyborg just because the same reason some people put leopard prints on their face. You know what I mean? There's just people that want to do that kind of stuff.
Get ripped.
Yeah, they prefer it apparently.
Yeah.
And then there's always going to be robot people because humanity can't help itself.
Right.
So
Right.
yeah,
And
I
we're all
agree.
going to live together. That's the cool part. But then in the future, we all come together. I'm not exactly sure how that's going to look or be, but yeah, it's like right now we're actually splitting apart, and you know that the the splitting apart. Oh my god, I lost it. I lost it again. Oh my
It's all
god.
right. We're all good.
Yeah, I guess it
Well,
wasn't really that important.
yeah, we're all diverging paths right now.
Right, right. That's it, man. We're splitting, and then eventually we got to come back together because, and it's like I don't know. It adds another complexity to the whole diversity.
Yeah. You know, I think it'd solve faster if we got to the point where we could make our lifespans 300, 400 years. But to be honest with you, if they don't do that, cyborg might not be a bad thing.
Right.
I mean, I guess you kind of have to look at it in what age you're in. Some people are absolutists where they're, no, no, I mean, humanity no matter what.
The eyes, man. That's going to be the biggest one. I imagine would be the eyes. Replace the eyes with cybernetic eyes, so that people that have got bad vision can see again. You know
I think that might end up being our biggest mistake.
what the eyeballs.
Yeah. It's, you have to understand everything is light, and the different things that are inside, the sensories that go on inside there
Hmm.
control a lot of the stuff in your body.
Yeah.
And once you lose that, there's a lot that goes away with it. And I think that'd be, because right now you go in and get LASIK. It used to be they cut your eye, you know what I mean, with a razor blade and get in there and fix it. And now they just put you in there and they put these things on you and it's light. They're showing different lights in there. And then your eyes are fixed, right? So how is that possible? But then when you go outside and it's a hot day and you see the sun and you feel energized again, part of that is your optic nerve taking in the energy all around you.
Vitamin D.
Yeah.
Yeah.
But it's all created through your optic nerve. So that's a big sticking thing. You
But
may,
hey, I mean, if you know this, if we
Mhm.
know this, you can artificially create it. It won't be the same. It'll be like digital music and listening to music on a record. You know, the record is always going to be the more precise sound, and the digital is always going to be not quite right.
I I could see it that way. I just think there's more to it.
Okay.
There's, you know how they always say it, like in the future you just get in a bed and then you're fixed. They
Okay.
push a
Yeah.
button and then they fix you. You know what I mean? You see
Yeah.
in a lot of sci-fi movies.
Yeah.
I think
Not
that's
quite Star Trek, but yeah.
yeah. I think it's
Yeah.
just solely based on frequency and light. And once we figure that out and we get it in there, it's done. It's like Rife. Rife figured it out through his scope, and the medical community shut him down and ostracized him. And once we figure out what he did again, we'll learn a lot more. And I think that that whole futuristic look may be true.
Yeah, maybe we could leave the eyes out of it. Maybe we don't have to deviate for necessity. Maybe it will, like you said, deviate for pleasure or
There you go.
desire. Like, yeah, I want claws, so I'm gonna go get claws, or I
There
want
you go.
you know,
People with the horns. I've
yeah,
seen those.
I want some horns. You know,
People just want spikes on their head. They just, you know what? Looks good. I want a spike collar right here. And then they go get them implanted. I've seen all kinds of weird stuff, man. People getting tails. You know what I
oh
mean?
yeah, yeah, yeah. The cosplay stuff, man. It's like,
Yeah. They're now furries. Is that, I think, what they call them?
okay, yeah. And I'm not sure, but I know what you're talking about. Like, uh, there's this one. I don't even know, man. I'm not gonna go there, call out names or anything. But there's definitely I've seen a lot of that, mainly online. I don't know. People around where I'm at are kind of simple. I mean, they don't. There isn't a lot of that. Tattoos are big. I mean, I live in the D, so I mean, tattoos are huge. But anything beyond that's pretty like not frowned upon, but not like smiled at either.
Oh, gotcha. It's not like California. I understand. It's not like a lot of people who come in from different areas have culture shock when they come to California because it's so different. It's like all that stuff is everywhere.
Yeah, like my niece lives in Los Angeles, and she likes it busy, so that's where she is.
Yeah, no thanks. I'll be honest with you. If I had a big studio, like I don't want to say just a huge building, okay, and I had like a little studio apartment I can go sleep in, you know what I mean, a little kitchen, I would love that. I don't need anything else. Just give me a huge studio to do what I want and all my little toys and gadgets and everything. You know what I mean?
Yeah,
I,
give me a nice room in the back to house everything, so I can keep the main room kind of flowing.
yeah,
But
I
yeah, yeah,
don't need a huge living room or anything, man. I'm pretty simple like that. I do everything on my computer, my desk, and you know what I mean, around my area. And I like to build experiments, and I like it right here in front of me. So, I mean, if I had something double this size, it'd be perfect. I'd be a hermit. You like barely see me. I'd be the guy that goes to the post office. You know what I mean, every month or something.
no, this
Just
is your garage, yeah, like a half of it,
oh
or is it
yeah,
not
this
a
is
garage?
it's like a 2 car garage,
Okay.
and I have I just put laminate flooring down, and I put the cabinets in behind me, and then I got a nice island, and you see the garage door behind me,
Yeah, yeah.
and then I got my printer set up, and then I have my computer over here. I have my desk over here. I got a whole thing built out here like a little studio. The problem is I'm a big guy and I knock over everything. So I'm
It's a little
constantly,
tight.
yeah, constantly turning and my big ass hits something and it just kind of jumps off of the table. You know what I mean?
That hopefully that hasn't caused you too much pain. Uh, I mean that could be quite costly actually, depending on what falls.
Oh yeah. I've had some expensive stuff hit the trash, that's for sure.
Oh,
Yeah. So that's all good though. I like it this way so I can work in here and do everything. It keeps me out of the house. My kids are, they're all over 21, so or over 20, I should say. But they could do whatever they want in the house. You know what I mean? Lounge around, do whatever,
mhm.
and they don't have dad in there just sitting there watching TV all day in retirement.
Right.
So they
You're
get
up and
to,
you're moving around and you're doing stuff and you're doing what you like to do. That see that not everybody gets to that point, and not everybody knows what that point is doing what they like to do. I mean, so that it's now I don't know what I like. Yeah, I think that's what that means.
yeah,
uh,
a lot of people just retire and watch the news all day and yell at the TV. That's basically what I see them doing. And they get all dumb about that stuff and they didn't have to go to work, so they go out and get in these stupid confrontation things, and there's no reason for it, man.
right.
I'd much rather do what I do and just play with my Tesla coils or go out and build a motor or something, or I mean just sit here on the internet and talk. Much happier doing all that.
So I want to know how I can start using the atmosphere with my pulse motors, and if that's even a possibility to use the cold circuit with my pulse motors. I don't know if it'll work, but give it a shot.
So let me see. You got high voltage potential going on because you got the back EMF spike. You have to amplify the back EMF spike in the system in order to start using that type of energy.
Okay.
So you want to play with the the yeah EMF, okay, of it, and then what you also want to do is start playing with your ground connections.
Okay.
So normally you probably wouldn't put many grounds and things, but when you hook up lights and everything, if you have a nice solid just earth ground, not ground to the house, but an earth ground, then you could start more directly playing with the entropy in the air and stuff like that, the capacitance in the air. Most of that stuff is in high voltage when you get to it, but
Okay.
that's where the spike is. So
Yeah, about 750 volts.
yeah, so you got to get that spike high enough. But yeah, you can absolutely use it, and you can also use it if you have an old antenna from a TV back in the day. You can use one of those to pull in energy just from the air. So that's how I would start incorporating it. Is start to when you put in light bulbs and stuff, start hooking earth grounds to it and see what happens, and then go from there. See if it starts to work in your system.
Okay. I will definitely be doing some experimentation.
Yeah, that's why it's easier with Tesla coils because they're already open air. They mess with the environment no matter what you do.
Because I mean, it might not be the wheel that's doing the in interaction. It's going
You're
to be the
structuring the
circuit.
environment with a magnet, and then with the electromagnet, you're doing the same thing.
Okay.
So if
Yeah.
put it this way, take a coil, put it on a stand, put it outside the magnetic field, right? As you spin it, and then just put your what is it called? Your volt and amp meter right there on it. Those little prongs. Sorry, I forget the name. And just move it out an inch at a time or a half inch at a time, and you'll start
Oh,
to see in your map where the field is.
like your motor, your four magnet motor. That
Yeah,
yeah. I remember that experiment too. That was pretty cool. And you
you
had
can map the field.
yeah, I like how strong it is and how far it goes out.
You'll find the sheath zones too, because those will be the zones where it goes like this, and then boom, it'll drop off, and then it'll go like this, and it'll drop off again and do it again. Every one of those is sheath zoning
Okay.
because it's creating vortexes.
So
So
that's just the magnetism from my wheel, right?
mhm,
Okay. Sweet.
magnets rotating do it, so you'll be able to find it, and you know what I mean, write it down, see how far you get to it. Then the cool thing would be once you find that out, now can you put coils on the outside of that? You've already got counter rotation between the two. Can you get the third ring running?
Yeah. And I know, well, I mean, I've been thinking about ways to do that since you mentioned it, that the electromag uh would be in the middle of two um permanent mag, or maybe even an electromag and one electromag in the center, and then the electromags out, and then the permanent mags on the third one. I don't know exactly how I would do it, but I'm planning on making my counter rotator um, a counter rotating device that incorporates all three instead of
Mhm.
just the two.
Um, I do have a way. See if this sounds simple enough. You want to make it like a DC motor. So you want where the wires come down, and then you want it to go into this plastic piece with little slots. Okay,
Hmm.
and then you want the brushes to hit it on the sides, just like a DC motor would, right? That way, it'll pick up the pulses. Every time it goes through, it picks up the pulse. Okay, so you could set it any way you want to, but then where it goes, you go a little bit up from it, and you put in a bearing there, and that can run your other wheel. So you can get three rotating wheels, different directions. You mean just from that?
Oh yeah. Um, I mean on the same shaft too, like the
Yes.
same shaft. Yeah, it's probably in part of the whole thing. It has to be on the same shaft.
Yeah. Same shaft. Because you can't rotate anything outside of that. They can't counter rotate each other unless it's floating, which
Right.
would mean some kind of magnetic field would have to be in place to get it to float. But yeah, all same shaft, you can get three different runs. If you take the electricity to the center, then it has to be pulled out just like a DC motor would with brushes, and just put up your what's it called, your bearings where you need to build it out. You know what I mean? Have things run underneath stuff. If that's what it takes to do it, yeah, you can do that.
I made this one video where I put a coil just out, and then I put my two Utrons, two of my
Hmm.
rotating Utrons on either side of the coil, and they both spun at equal, speeds. It was really cool. Um, so I'm wondering if maybe there's a way that I could utilize both sides of the electromagnet. Uh,
Oh,
and have
gearing,
it be, hmm?
magnetic gearing.
Yeah, yeah, kind of simpler. Yeah. It's not simple, but I mean, it's like, uh, you know
No,
what I'm
no.
trying to say.
Yeah, small rotating body in the center for high torque, and then you get it out to the outside of it, and it changes the gearing. The rotations per turn based on the amount of magnets on it and the size of the disc itself. Magnetic gearing. Yeah.
Yeah, but but it's gonna tie like permanent mags in the middle, really small disc of permanent magnets in the middle, like that would be either on the shaft or just right around the shaft like this, and then the second ring outward would be electro mags,
Hmm.
um, that we would utilize both sides of those electro mags. And then on the outer side would be maybe more magnets, but more permanent magnets. Um, and both permanent magnets rings would eventually spin in the same direction, and the electron mags would spin in the opposite direction. I don't know if it'll work.
Well, if you use the gear ratio of it to go back to the original motor, you might be able to spin it faster.
Okay.
I mean, you have to work out, the sizes of each one of them. But it's a simple gearing system. See how gears work and see how big the cogs are, and then do the same thing with the magnets.
And then yes, that's another thing I wanted to experiment with is gearboxes. Like you have the motor spinning at a certain speed, but then you put it through a gearbox, and there all of a sudden you're going 10,000 instead of
But
6.
that's exactly what I'm saying. It's take your original wheel, now take a small wheel, okay, and then you can go to a medium sized wheel. Each one of them is a different planetary gear or
Wow.
regular gear you can put around this thing, and you can make gearing. You can go height gearing on it based on what you're doing. You got to remember, you're only utilizing one section of a 360-degree field.
Hmm.
So you're going like this, you're thinking this, and then you're thinking out here, right? But did you think about this angle? Did you think about this angle? You know what I mean? What are you doing
No,
with those?
I haven't thought about it because in the design that I have in my head currently, all that is PLA up here and down
Mhm.
here. And that's pretty much what it is right now. But I mean, like, if I started thinking on other dimensional, instead of up, back, uh, left to right, all the different directions.
It's like take an axle flux motor, put it on the bottom, the actual winding,
Mhm.
and then now have your two magnets, right? As you pick up counter rotation, it automatically fields the axle flux coils on the bottom. So you have more energy coming out of there. So you go magnet, the windings for the axle flux, magnet. Now spin yours and get it to counter rotate. Now all the spin that goes on there is free energy on the axle flux on the bottom. You can axle flux it on the top. Okay.
Mhm.
And then you can use the outside as gearing. And every one of those gears, you can axle flux it on the bottom and top as well. You could literally have an immense amount of power coming out of this thing by just learning how that works and doing it right.
Yeah, it
That's
sounds like where I want to be at with the knowledge and everything. I mean, it sounds sound.
Oh yeah. Well, it sounds like a fun project, to be honest with you. Give you something to do forever. Maybe
Yeah.
never get bored, I'll tell you that. There's a ton of stuff to build out of that and different ways to do it. You know what I mean? It's just
Yeah,
yeah,
I encourage anybody to uh, think about how it's put together, and if they could have maybe a better way to do it. I'm
mhm.
all ears. I mean, I've done it like 15 different ways myself with this model. So, and I've got like 8 different models that I've done through the 3 years. with brushes. I've done brushes. I've done, uh, you know, this. I've done external trigger coils. I've done, pretty much not everything, but I've done a lot. I've done a lot of counter rotation experimentation with the pulse motor aspect of the whole thing.
Mm-hmm.
And I
Yeah.
think it is where it's at. I think counter rotation is definitely a booster of power and output.
Mm-hmm. Now, when I did my counter rotation, there was no core. So they're open cores too. So even where it counter rotates, if you put a lining of wire, you're still getting energy out of it.
Mm-hmm.
So it's it's so interesting how each part works and how much you could pull out of each one of them. And the engineering isn't overly difficult. It's complicated. You know what I mean? And how to run one thing over another and put bearings in there. It's never an easy task. But once you get past that, the rest of it is pretty straightforward.
And the answer you get is pretty straightforward as well. It's a law, in my opinion. It's nature at work. It's physics demonstrating itself to you through counter rotation, equal and opposite reaction. It's how things work when they are interacting with one another.
Yeah.
At least that's how I see it, based on what I do.
I always say it's like a safe lock. One side turns one way, the other side turns the other way. Then you turn it back the other way. It's a safe lock.
Oh yeah, I got you. Like a combination
Mm-hmm.
lock. Gotcha.
Yeah. All right. It's been 3 hours, man. I'm about done for the day.
Okay. Thanks for having me.
Oh, dude, thank you for being here. Hey, I just want to shout out Ulysses one more time, man. Thank you very much. I appreciate it, man. You're helping out the cause, and we're going to be building some cool stuff for that. I want to thank Papa Bale here for hanging out with me today, man. Just talking shop. Totally awesome, man. I appreciate that.
Thank you.
You have anything coming up that you're doing? Anything special, or just you're running normal show, or what do you got going on?
Well, I'm probably gonna take a nap, and then and then because I was up till 4 in the morning putting it together just to make sure that it worked, and I did it because it worked. It didn't work. Never mind. Anyway, thank you.
Uh, hey, get me that. You gave me the schematic already. I already have it. Kind of show me, just get a top down picture if you can of what you're doing. And then I'll help you lay that thing out.
You want me to show you? There's the rotor right there. It's not a top down though. I don't know if I can make it over there. Here, let me try this.
Oh, you could always do it later and send me the picture to my email because just need to see what you got going because those circuits sound small. Yeah, just send it to me later. Just send me
Okay.
a top down, so I don't forget anything, and then I'll rewrite a schematic for you and send it back.
Okay. Absolutely.
Yeah, and then I'll send you the piezo the link for that too.
Okay. That's great because that'll probably get me over Unity right away. I mean,
It probably will. That's Mike said it really improved the system, and I have things on here through my Jewel Thief circuit that I use that shows the piezo doubles the power. It shows it right on my oscilloscope easy.
awesome.
So anyway, I want to thank everybody for watching today. Chat, you guys have been awesome, man. Thank you for hanging out with us today. I really appreciate everything.
Thank you. I didn't see any of it. I'm sorry. Uh s-
No, we're all good, Papa Bale, man. Thank you for hanging out with me, man.
yeah, thanks.
Uh,
Appreciate it.
old man built. The old man built. The old man built. The old man built.
The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.